The wind is sharp tonight. It whispers low across a white expanse that seems to have no edge tugging at the hood you've pulled tight around your ears. Your boots crunch into snow, older than anything you've ever touched. Snow that fell before there were cities, before there were kings, before anyone carved their names into stone. The air tastes clean in a way you didn't know air could taste dry as chalk, carrying just the faintest scent of ice and time. Above the sky isn't black, it's a deep, slow blue, the kind that feels like it's been holding its breath for thousands of years. Somewhere under your feet, far beneath the frozen crust, there are secrets. A forest sealed away midsummer, its leaves still green. The bones of giants who once roamed in herds, their last steps frozen into the mud. And buried deeper still, particles, metals, and fragments of something that might have fallen from the sky, marking the instant the world shifted from warmth back into bitter cold. You probably won't survive this well, not if you were actually here 20,000 years ago. The air cuts, the nights never end, and food is whatever you can run down before something bigger runs you down. This is the Ice Age, and it's not the cartoon kind with slapstick mammoths and clumsy tigers. It's silent most of the time. Too silent. Until something breaks. That silence sometimes forever. So before you get comfortable, take a moment to like the video and subscribe. But only if you really like what I'm doing here. People have walked here before on this ice that no longer exists. They've left footprints so crisp you can still see the toes pressed into the shore of a vanished lake. They've crossed bridges of land, now drowned beneath frigid seas, carrying stories and tools and memories of the old world behind them. And in places we never thought they could reach, they've carved shapes into stone, or left behind caches of bones for reasons no one can quite explain. The Ice Age didn't just build mountains and glaciers, it built mysteries. Some are written in the black carbon bands that stretch across continents, the thin scar of an event so sudden and so strange that even now scientists can't agree on what caused it. Others are carved into the ground in patterns so perfect they could be mistaken for art, yet may be nothing more or nothing less than the frozen breath of the earth itself. We'll walk through places where predators outnumbered prey, where craters yawn open in the tundra as if the land is exhaling for the first time in thousands of years. We'll follow mammoths into their last summer stand beside lakes big enough to tip the world's climate when they drained, and dive beneath the waves to see the coastlines our ancestors knew, now buried under the sea. Now turn off the lights, maybe turn on the fan for some soothing noise, and let's get started on tonight's journey together. The cold doesn't announce itself. It seeps in quietly the way water finds a crack. You're standing on a plain of ancient ice, but it's not the flat, glassy kind you might imagine. It's ridged and scarred with deep blue crevasses yawning in places you don't expect. Far to the south, there's a slow greening of the land as the ice retreats. The earth, it seems, is finally shrugging off the last long freeze of the last glacial maximum. And then it changes its mind. It's around 12,900 years ago, and global temperatures had been inching upward. The great ice sheets blanketing North America and Eurasia were melting, rivers were swelling, and forests were pushing north. For humans, this was a cautious gift. Game was returning. Plants were growing in places long barren, and the world felt as though it might finally tilt towards something gentler. But in geological time, peace can be an illusion measured in minutes. Almost without warning, the warming stops. The air turns sharp again. Storms return, and the ice reclaims ground it had surrendered. This is what scientists now call the younger dryas, a sudden violent return to glacial conditions that lasted about 1-200 years. And sudden here doesn't mean over a few centuries. Ice cores from Greenland show the drop may have happened in as little as a decade, maybe even a single year. For you standing in this world, the change would be terrifying. Summers grow short and cool. Winters bite harder and stay longer. Animals vanish from the edges of your hunting range. If you're a reindeer herder, or more likely a reindeer hunter, you watch herds dwindle, the rhythm of migration breaking apart. Rivers you once forded are locked in ice. The hunger season stretches into something like permanence. Mainstream climatology offers one leading explanation, the meltwater pulse theory. Imagine the vast glacial lakes dammed up behind walls of ice in North America. Lake Agassiz and Lake Ojibwe together held more fresh water than all the Great Lakes combined. Now imagine those ice dams breaking not slowly, but catastrophically, sending a torrent of fresh water surging into the North Atlantic. The ocean currents that carry warm tropical water northward, the Atlantic meridional overturning circulation, suddenly falter or even shut down. Without that warmth, the northern hemisphere plunges back into deep cold. It's a neat explanation. Too neat, perhaps. Because even if meltwater started the younger dryas, how did it end so abruptly? Climate systems don't tend to restart themselves in an instant. Some scientists suggest the ocean circulation rebalanced once the influx of fresh water slowed. Others suspect a bigger shove from outside the Earth itself. This is where things get more controversial and more interesting. Enter the younger dryas impact hypothesis. According to this idea, Earth crossed paths with fragments of a disintegrating comet about 12,800 years ago. Pieces slammed into ice sheets or exploded in the atmosphere, releasing energy equivalent to thousands of nuclear bombs. The impacts would have vaporized ice-started continent-wide fires and flung fine dust and water vapor into the stratosphere. Sunlight dims. Temperatures crash. And the younger dryas begins not as a slow freeze, but as an impact winter. Supporters of this theory point to physical clues. Layers of sediment dating to this exact time contain microspherules, tiny glassy beads formed at extreme temperatures, along with elevated levels of platinum and even nanodiamonds. These aren't the sorts of things you get from a normal forest fire or gentle climate shift. You get them from something violent, something hot, something cosmic. But like all good Ice Age mysteries, the evidence is frustrating. Not every site from this period shows these markers. Critics argue that volcanic eruptions, lightning strikes, or even industrial contamination could account for some of them. And the biggest missing piece, an obvious crater. If there was an impact, where's the hole in the ground? Proponents counter that if the comet hit an ice sheet, the crater might have melted away, leaving only scattered geological fingerprints. Or perhaps the impacts were airbursts, like the 1908 Tunguska explosion in Siberia, which flattened trees for miles but left no crater. If you were alive, then you wouldn't care about the scientific debate. You'd care about survival. And survival would suddenly mean facing a world that felt hostile again. For hunter-gatherers across Europe, Asia, and North America, this was the second ice age in one lifetime. You might tell stories to your children about the time when summers were long and rivers ran free, stories they would pass down like inherited memories. Interestingly, such memories may still echo in some of the oldest myths on Earth. Indigenous oral traditions from the Americas speak of fire from the sky darkness at noon and floods that followed. Across the ocean, in the ancient Middle East stories of catastrophe and rebirth appear in myths predating written history. At Göbekli Tepe, in modern-day Turkey, an enigmatic megalithic site dated to about 11,000 BC, some researchers believe certain carvings depict celestial events, perhaps even a comet strike. If true, it could mean that human culture was responding not just to climate change, but to trauma on a planetary scale. By the time the Younger Dryas ended around 11,700 years ago, the change was as abrupt as its beginning. Greenland ice cores suggest temperatures rose by as much as 10 degrees Celsius in mere decades. The ice retreated rapidly. Sea levels surged. And for the first time in tens of thousands of years, the climate stabilized into the relatively warm and gentle Holocene epoch, the one we still live in today. It's tempting to think of this as the happy ending. The world warms, agriculture begins, cities eventually rise. But the Younger Dryas leaves behind questions that still haunt climate scientists, archaeologists, and storytellers alike. Was it a freak twist in Earth's oceanic and atmospheric systems? Or was it written in the stars, the result of debris from a broken comet falling through our skies? Standing here on this ancient plain, you can't see the answer. The horizon is flat and white, the air brittle in your lungs. Somewhere far to the south, forests are dying back under the return of winter. Farther still, people you'll never meet are carving animals and abstract shapes into stone, perhaps to remember or to warn. And above you, in the deep blue of a sky untroubled by modern light, the faint trails of meteors trace lines that no one will understand for thousands of years. For now, all you can do is pull your furs tighter, shift your weight on numb feet, and keep walking. The cold has returned, and it intends to stay a while. You've been walking for days across a windswept steppe where the horizon seems to slide away each time you get close. The air smells faintly of dust and dry grass, but there's another scent, too faint, metallic, and older than memory. Ahead, dark shapes break the monotony. At first, you think they're boulders. Then one moves. A woolly mammoth raises its head. It's taller than any living elephant you've seen in zoos back home, with long, curving tusks gleaming like polished ivory and a coat the color of burnt straw. Its eyes are small but sharp, and they follow you with the patient attention of something that knows exactly how big it is. Around it, a dozen more graze on tough sedges and wind-stunted shrubs. You can hear the slow tearing of roots from the frozen earth and the muffled thud of heavy feet. For hundreds of thousands of years, mammoths like these roamed the Mammoth Steppe, a vast belt of grassland stretching from Spain through Siberia to North America. They were more than animals. They were ecosystem engineers. By trampling saplings, grazing down woody plants, and fertilizing the soil, they kept the steppe open and rich in grasses. That grass fed herds of bison horses and musk ox, which in turn fed wolves, lions, and humans. They'd seen ice come and go before. Through multiple glacial cycles, they'd adapted thick fur, small ears to minimize heat loss, and a fat hump at the shoulders for energy storage. But this time, the ending would be different. Around 10,000 BC, not long after the Younger Dryas drew to a close, mammoth populations across Eurasia and North America collapsed. The decline wasn't perfectly synchronized. In Siberia and mainland North America, they vanished early. In pockets like Wrangel Island north of Siberia and St. Paul Island in Alaska, small herds survived for thousands of years longer. On Wrangel, mammoths still walked the beaches while the Great Pyramid of Giza was under construction. But by 2000 BC, they were gone everywhere. Why? The most obvious suspect is climate change. As the Holocene warmed, glaciers retreated, seas rose, and the vast mammoth steppe began to shrink. Grasslands gave way to forests and wetlands. For a grazer adapted to cold, dry expanses, this was bad news. Less open space meant less food and more competition with other herbivores. But there's a problem with this explanation. Mammoths had survived warming periods before. The end of earlier ice ages didn't kill them off. Why now? That brings us to the second suspect, us. Wherever humans expanded into new territory, megafauna often disappeared soon after. Archaeological sites across Europe, Asia, and the Americas show evidence of mammoth hunting spears embedded in ribs bones, split to extract marrow, entire skeletons stacked in patterns that suggest mass kills. Some ancient communities built dwellings from hundreds of mammoth bones carefully fitted together like puzzle pieces. The overkill hypothesis argues that even small scattered human populations could have had an outsized impact. Mammoths reproduce slowly. Calves are born only once every 4 to 6 years. If hunting pressure removed more animals than were born each year, population collapse could follow in just a few centuries. It wouldn't have required malice, just persistence and skill. Still, this theory doesn't explain everything. In some areas, mammoths disappeared before humans arrived in significant numbers. In others, they lingered for millennia alongside human communities. Then there's the third possibility: disease. Imagine a pathogen carried by humans' dogs or other animals that spreads quickly through herds already weakened by shrinking habitat. A virus or bacterium, targeting their respiratory systems, digestive tracts, or immune defenses. We have no direct evidence for such a disease, but rapid, wide-scale declines have occurred in modern wildlife under similar conditions. And finally, the wild card cosmic catastrophe. The younger Dryas impact hypothesis doesn't just try to explain sudden cooling, it also offers a mechanism for megafaunal extinction. If fragments of a comet or asteroid exploded over ice sheets, the resulting fire shock waves and debris could have devastated ecosystems. Soot in the atmosphere would block sunlight, cooling the climate and reducing plant growth. For mammoths already hemmed in by changing vegetation, it could have been the final blow. Supporters of this idea point to black mat sediment layers found in some mammoth kill sites. These layers contain microscopic spherules, platinum, and other materials associated with high-temperature events. Critics counter that not all sites show this evidence, and alternative explanations, volcanic eruptions, lightning strikes are possible. If you were living alongside mammoths at the time, you wouldn't be concerned with theories. You'd notice the herds thinning year after year. The trails you once followed across the plains would grow faint. Hunting would become harder. You might tell your children about the time when the ground shook with the sound of thousands of feet, and their faces would be blank. They'd never seen it. And yet mammoths never entirely left us. Their image appears in cave paintings from France to Russia. In the frozen north, ivory tusks have been carved into tools, ornaments, and figurines for tens of thousands of years. In Siberia today, the melting permafrost still yields tusks so fresh that they can be carved and sold. Some of those thawed carcasses are so well preserved that scientists have extracted DNA, muscle tissue, and even blood. This has sparked serious discussions about de-extinction using genetic engineering to create hybrid elephants with mammoth traits. The goal wouldn't just be novelty. Proponents argue that reintroducing such animals to Arctic regions could help restore grassland ecosystems and slow permafrost thaw by trampling snow, keeping the ground colder. Whether or not that happens, the fascination endures. There's something about the mammoth, a blend of the familiar and the alien that captures the imagination. It's an animal we can almost touch across time, one we've known both as predator and as co-inhabitant of the same landscapes. Picture this. It's a late summer evening on Wrangel Island, about 3,500 years ago. The sun is low, the air sharp with salt from the Arctic Ocean. A small herd of mammoths moves slowly along a ridge, their silhouettes black against the orange sky. Down below, waves break on a stony shore. Somewhere, a thin column of smoke rises from a human camp. The two species are aware of each other, as they have been for tens of millennia, and in a few centuries, no more than a blink in geological time, one of them will be gone. No one in that moment can sense it, but the world is closing over the mammoth story. The ice will retreat, the grasslands will dwindle, and the last echo of those deep rumbling calls will fade into the wind. For now, though, the mammoth lifts its head to the breeze, flaps its ears, and moves on. The ground still trembles under its weight. the step still belongs to it for just a little while longer. The first thing you notice is the darkness, not the kind that fills a room at night, but a thin, tangible shadow lying just beneath the surface of the earth. You wouldn't see it unless you were digging, maybe to plant, maybe to build, maybe by accident. One moment, the soil is its usual pale brown or sandy gold, and then suddenly you strike it a band of black, only a few inches thick, running flat and unbroken through the ground, like a line drawn across a page. It's not coal. It's not asphalt. It's what archaeologists call the black mat. This layer appears in sites scattered across North America and even beyond Arizona's desert canyons, the grassy wetlands of South Carolina, the high plains of Alberta, and as far afield as parts of the Middle East. It's almost always in the same position in the soil profile, about 12,800 years old, and it almost always sits directly above the last traces of certain animals and the last tools of the Clovis people. Below it, mammoth bones, mastodon, teeth spear points. Above it, none of those things. To the untrained eye, it just looks like dark dirt. To a scientist, it's a sharp boundary between two worlds. Mainstream explanations for the black mat start with climate. Around the start of the younger dryas, temperatures dropped sharply. Glaciers advanced again. Rainfall patterns shifted, and in many areas, wetlands expanded. In these wet, stagnant conditions, plant matter algae and fine silt could accumulate and decompose, slowly turning into a dense carbon-rich band of soil. In this view, the black mat isn't a mystery. It's a natural product of a wetter, cooler world. And yet things don't quite add up. In some places, the black mat isn't just rich in organic material. It's flecked with microscopic spherules, melt glass, and nanodiamonds. These are tiny particles formed at extreme temperatures, the kind you'd expect from a meteor impact or other high-energy event, not from the slow decay of plants. There are also elevated levels of platinum and iridium elements, more common in meteorites than in Earth's crust. At Murray Springs in Arizona, the black mat caps the last known mammoth bones in the region. At the Topper site in South Carolina, it lies directly above Clovis artifacts. It's as if a curtain fell across the continent before the line a thriving Ice Age world. After it, something new, something diminished. Proponents of the Younger Dryas impact hypothesis see the black mat as a smoking gun. They argue that around 12,800 years ago, fragments of a disintegrating comet struck the ice sheets or exploded in the atmosphere, showering the land with molten debris and igniting massive wildfires. The soot and carbon from those fires, combined with fallout from the impacts, settled into this distinct dark band. The timing matches perfectly with the sudden cooling, the extinction of many large animals, and the disappearance of Clovis culture. Skeptics push back hard. Not all black mats contain these exotic particles. Some appear to have formed decades or centuries after the Younger Dryas began. Others exist in regions with no signs of catastrophic fire. Could the melt glass and nanodiamonds come from something else? Volcanic eruptions, lightning strikes, or natural processes? We don't fully understand. The debate is fierce. Papers are published and counterpublished, each side picking apart the other's methods. Some scientists argue that the impact theory relies on selective evidence. Others counter that traditional explanations ignore too many anomalies. Step back from the academic battlefield, though, and the black mat remains unsettling. Imagine walking across a grassy plain 12,900 years ago, hunting bison or gathering plants, completely unaware that something comet flood fire, or all three, is about to redraw the map of life around you. Fast forward 12 millennia, and we're sifting through the dirt, trying to piece together what happened in the instant between before and after. Even beyond North America, there are hints of similar events. In Syria, ancient lake beds show unusual dark layers from around the same time. In Greenland ice cores, there's a spike in platinum levels, dating precisely to the younger Dryas onset. Could this mean the black mat story is part of a global event? From a storytelling perspective, the black mat is tantalizing because it's so literal, a physical line marking the end of one chapter and the start of another. Above it, people adapt to a colder, more uncertain world. They change the way they hunt, the tools they use, even the stories they tell. Below it, an older order persists, confident in its rhythms, unaware of the shadow creeping over the horizon. One theory, more speculative than most, suggests that the black mat is not just a record of environmental change, but a kind of warning. If the impact hypothesis is right, then these layers are the fingerprints of something that could happen again. Earth still passes through the torrid meteor stream twice a year, the same debris field some researchers think delivered the younger Dryas impacts. What if buried in this thin layer of carbon and glass is a message about how quickly the familiar can vanish? The oddest thing is how quiet the black mat looks in the field. Archaeologists describe it as a muted, unassuming presence, just a band of dark soil you could mistake for a campfire stain. But once you know what it might mean, it's impossible to see it without feeling that flicker of unease. You crouch down, run your fingers through the grit. It's light dry, almost silky. Somewhere in here are the atoms of animals that haven't walked the earth in 12,000 years, and perhaps the dust of something that fell from the stars. And in the still air above the dig site, you can almost imagine a sound from far away, like a low rolling boom, fading into the distance. A sound no one alive today has ever heard, but that once echoed across a continent as the sky lit up and the world changed forever. From the ground, they don't look like much, low, shallow depressions in the sandy soil, most no more than a few meters deep. Some are big enough to hold a pond fringed with reeds. Others are dry bowls rimmed with pine or scrub oak. But climb into a plane, or better yet, look from a satellite, and the land transforms. Stretching for hundreds of miles along the Atlantic coastal plain, from New Jersey to Florida, and inland into the Carolinas, thousands upon thousands of these depressions appear. They are almost perfect ovals. Each one is tilted in the same direction, northwest to southeast, like they've all been brushed by the same invisible hand. They range from the size of a small backyard to more than 10 kilometers long. And here's the thing, they're all Weirdly, the same. These are the Carolina Bays. Their name is misleading. They aren't actually bays in the oceanic sense, and they aren't confined to the Carolinas. The term bay comes from the bay trees that often grow in the wettest ones. Early European settlers noted them, but didn't dwell on their origins. It wasn't until aerial photography in the 1930s that their scale and pattern became obvious. Imagine being a pilot flying over South Carolina farmland and suddenly seeing hundreds of these precise shapes carved into the earth. The mystery is how they formed. The most accepted explanation in mainstream geology is that they are relict features from the last ice age shaped by wind and water over tens of thousands of years. In this theory, the bays began as shallow depressions in sandy soils. Winds blew across them, elongating them in a consistent direction, while water gathered seasonally, deepening the hollows. Over time, vegetation anchored the rims, preserving their outlines. It's tidy, but it has its problems. Why are they so uniformly aligned over such a huge area? Why are their shapes so consistent, even in regions with very different local conditions? This is where alternative theories come in. One of the more dramatic ideas suggests that the Carolina Bays are the scars left by a massive meteoric event during the late Pleistocene, possibly even related to the Younger Dryas impact hypothesis. According to this version, fragments from a disintegrating comet or asteroid entered the atmosphere at a low angle, exploding above the Laurentide ice sheet to the north. The debris field extended hundreds of miles, and secondary impacts created the ovals by blasting into the soft, wet coastal plain. Supporters point to the bay's consistent orientation, matching what you'd expect from a shower of debris entering from the northwest. Some bays also show subtle raised rims, which could be the remnants of ejecta thrown outward. Critics argue there's no clear evidence of shock metamorphism. The microscopic changes to minerals caused by high-energy impacts in the bay sediments, and that wind and water processes can, under the right circumstances, produce similar shapes. A third idea tries to bridge the two. Maybe the bays began as meteor-related disturbances, later modified and standardized by wind and water. Over thousands of years, the original craters softened and stretched into the familiar ovals we see today. If you could drain the water from every one of them and walk their floors, you might find different stories. Some have sandy bottoms with no signs of high heat or pressure. Others contain layers of peat and clay that could hide microscopic clues to their origins. And a few, the deepest and least disturbed, might still preserve the fingerprints of whatever force carved them. For indigenous peoples of the region, these depressions were part of the landscape long before scientists began arguing about them. Some were used as seasonal fishing or hunting grounds. Others, ringed with fertile soil and protected from wind, may have been valuable for early cultivation. Oral traditions sometimes describe great fires in the sky or water falling from above, though it's hard to know whether these refer to local events, distant memories, or metaphorical storytelling. Standing in one today, you get an odd sense of enclosure. The rim is just high enough to block the wind, and the air inside feels still. In the spring, a chorus of frogs might fill the shallow water. In summer, dragonflies skim the surface. In winter, ice might crust the edges. The shape, though, once you've seen it from above, never leaves your mind. You can almost feel the curve beneath your boots, the subtle tilt toward the southeast. Theories multiply because the Carolina Bays are in a way perfect mystery fuel. They're numerous enough to study, uniform enough to suggest a single cause, and yet scattered enough to resist neat conclusions. Every explanation seems to answer some questions while raising others. One lingering curiosity is the sheer number of them, tens of thousands across the coastal plain. If they were the product of a singular catastrophic event, what kind of energy would it take to mark the land so many times without leaving obvious craters elsewhere? If they formed slowly, shaped by climate and topography, why don't we see modern equivalents appearing today under similar conditions? There's also the matter of their age. Radiocarbon dating of organic material from some bays suggests they're at least $20,000 to 30,000 years old, predating the younger dryas entirely. Others may be younger. This staggered timeline could mean multiple formation events, or it could mean that bays are like living features, altered and refreshed over millennia by changing environmental forces. Imagine, just for a moment, that you could see them form. Perhaps you're a hunter on the plain, tracking deer near a shallow lake. A roar grows in the sky. The air heats, and a blinding flash fills your vision. In the next heartbeat, the ground shudders, and the lake bed drops into a perfect oval depression, steaming and churning. Or, in a slower version, you return to the same spot year after year and notice the pool stretching, curving, reshaping itself under the combined work of wind, rain, and time until centuries later it matches the thousands of others. Both stories fit the evidence in pieces. Neither explains it all, and so the Carolina Bays remain caught between worlds, a product of gentle natural shaping or violent cosmic intervention, or maybe both. Every time you fly over the southeast on a clear day, you can look down and see them winking up through the forest canopy, quiet ovals holding on to their secret. Somewhere out there, maybe in a bay, so remote no one's ever cored it. The answer lies buried in a thin layer of sediment. Until then, they remain exactly as they've been for tens of thousands of years, shallow still, and just a little too perfect. It starts with an absence. You're moving through a valley where the hills are dotted with scrub, and the air feels sharp in your lungs. But something is missing, something big. No silhouettes on the ridgelines. No distant movement in the grass. No low grunts or trumpeting calls carried by the wind. The world feels empty. Once, not so long ago, this same valley would have been alive with giants. Woolly mammoths with their long, curving tusks. Mastodons, shorter, stockier cousins browsing in the forest margins. Great shaggy bison, heavier and more muscular than their modern descendants. Saber-toothed cats, crouched in the shadows, their canines gleaming. Lions twice the size of those in Africa today. Ground sloths as big as small buses, moving with deliberate power through the brush. And giant birds, like the terror bird Titanus, stalking the grasslands of the Americas. Now, nearly all of them are gone. And it's not just here this emptiness is global. Between roughly 50,000 dollars and 10,000 years ago, in a span of time short enough to fit into a single human story, the world's megafauna vanished in waves. Australia's giant kangaroos and marsupial lions were gone first. Then the great beasts of the Americas. Europe and Asia lost their mammoths, cave lions, and woolly rhinos. In Madagascar, hippo-sized lemurs and elephant birds disappeared. The pattern is so widespread, it's called the quaternary megafaunal extinction. The scale is staggering. On continents and large islands across the globe, more than 70% of large animal species, over 100 pounds, vanished. The smaller animals mostly survived: rabbits, foxes, antelope, but the ecological top tier collapsed. And with it, entire ecosystems reshaped themselves. Why did it happen? That's where the arguments begin. One camp points to climate change. The end of the last ice age brought warming glacial retreat and rising seas. Habitats shifted dramatically. Grasslands became forests. Wetlands dried out, coastlines flooded. For animals adapted to very specific environments, these changes could be catastrophic. Cold-adapted species like the woolly rhino may have had nowhere to go as their ranges shrank. But climate change has happened before. The planet has warmed and cooled dozens of times over the last few million years, and megafauna survived those shifts. Something about this time was different. The second camp points the finger at us. Wherever humans arrived, megafaunal extinctions often followed within a few thousand years or less. In Australia, the giant marsupials vanished soon after the first Aboriginal peoples arrive around 50,000 years ago. In North America, mammoths, mastodons, and giant ground sloths disappear within a millennium or two of human settlement. In New Zealand, the massive flightless moa birds are hunted to extinction within 2 centuries of Polynesian arrival. The overkill hypothesis suggests that humans armed with coordinated hunting strategies fire, and in some cases advanced projectile weapons, could wipe out slow-reproducing species relatively quickly. Even if hunting was not the sole cause, it could have pushed already stressed populations over the edge. Then there's the possibility that the two forces work together. Climate change weakened populations, fragmenting habitats, and reducing genetic diversity. Humans arriving into this stress system delivered the final blow. A third idea, more controversial, proposes a disease vector. Could early humans or their domesticated animals have carried pathogens that jumped into wildlife populations? Modern parallels exist. Rinderpest, a viral disease of cattle, spread into wild ungulates in Africa with devastating effect. A pathogen with high mortality in large-bodied species could have emptied ecosystems with frightening speed. And finally, there's the cosmic wildcard, the younger Dryas impact hypothesis, which we've already brushed against, links the sudden climate reversal 12,800 years ago with a comet or asteroid impact. The fire's atmospheric dust and rapid cooling could have delivered a 1-2 punch direct mortality from the event itself, followed by starvation and ecosystem collapse. The black mat layer in some extinction sites is part of this argument. Wherever the truth lies, the aftermath was profound. Without mammoths to trample and graze the mammoth steppe, transformed into tundra and boreal forest. Without giant herbivores in Africa, certain grasses and shrubs spread unchecked. Apex predators lost their primary prey and either adapted, shrank in size, or vanished themselves. For humans, the loss of megafauna was both a crisis and an opportunity. Large animals provided immense amounts of meat, hides, bones, and fat. Their disappearance forced communities to diversify diets, refine hunting technology, and domesticate plants and animals. In some cases, this shift may have nudged humanity toward agriculture, not because farming was easier, but because the big game was gone. Imagine living through it. You're part of a hunting band that's followed herds for generations. You know the migration routes by heart. You know where to set your traps, when to prepare your spears. And one season, the herds are smaller. The next season, smaller still. Within a decade, the great animals are memories told around the fire. Children grow up having never seen them except as carvings in bone or ochre-painted silhouettes on cave walls. The void they leave is more than physical. Many cultures wove these animals into their cosmology. They were spirit guides, ancestors, divine beings. To lose them was to lose part of the world's meaning. In some indigenous traditions, the disappearance of certain animals is explained as a withdrawal, a conscious decision by the creatures to leave after humans broke some ancient covenant. Today, the echoes of that extinction still shape our landscapes. The American prairies, African savannas, and Siberian tundra all bear traces of what they once were when giants walked among them. And modern conservationists sometimes wonder, what if we could restore those ecological roles? Not through cloning necessarily, but by introducing functional equivalents, large grazers and browsers to mimic the lost dynamics. Projects in Siberia's Pleistocene Park aim to recreate the mammoth steppe environment using bison horses and even proposals for resurrected mammoths. It's a reminder that extinction isn't just about losing species. It's about losing entire ways that ecosystems work. The Great Ice Age die-off was not the first such event in Earth's history, but it's the only one we've been close enough to witness through human eyes. And it leaves us with an uncomfortable question. If human arrival really did play a major role, how different would our world look if we had arrived more gently? The wind moves through the empty valley again. You try to imagine it filled not just with life, but with a living architecture of movement, sound, and scent. A place where every horizon had a shape against it, where every dawn brought the low thunder of hooves, or the deep rumble of a mammoth's call. Now, the shapes on the horizon are only clouds. The sound is only the wind. And the giants are gone, leaving behind a silence that feels heavier than the air itself. The flint still feels sharp under your fingertips, its edges catching the light like a frozen ripple of water. It's a Clovis point, sleek, symmetrical, deadly. Even without knowing its name, you can tell it's the work of a master craftsperson. The base is carefully fluted a channel, flaked away to allow it to be hafted to a spear. You imagine it slicing clean through the thick hide of a mammoth or mastodon, or through the ribs of a giant bison. This was a tool for big game made by a people who lived and breathed the hunt. The Clovis culture appeared in North America around 13,200 years ago and flourished for several centuries. They weren't the first humans on the continent. Evidence from sites like Monteverde in Chile and the White Sands footprints in New Mexico suggest people arrived earlier. But the Clovis left a footprint both literal and cultural. Their distinct stone tools, found from Alaska to Central America, mark one of the most widespread and recognizable archaeological traditions in the Americas. Clovis campsites tell a story of skilled hunters and adaptable foragers. In some mammoth bones lie in orderly butchery patterns the marks of stone blades still visible. In others, caches of unused spear points are buried carefully, perhaps for retrieval during a return journey. They lived in small, mobile bands, moving with the seasons and following the migrations of the animals they depended on. And then, just as suddenly as they appeared, the Clovis vanished from the archaeological record. By about 12,800 years ago, their distinctive points are no longer made. In their place, new styles and technologies emerge: Folsom points in the Great Plains, Dalton points in the southeast. It's as if a page has been turned in the human story, leaving behind an entire chapter's cast of characters. Why did they disappear? One explanation ties back to the megafaunal extinctions. If your hunting strategy is built around large prey, and those prey vanish, your culture either adapts or fades. For the Clovis, the loss of mammoths, mastodons, and other big game would have been catastrophic. Hunting smaller animals requires different weapons, different tactics, and often more time for less reward. In this view, Clovis people didn't vanish. They evolved, developing new toolkits suited for a changing world. Another explanation is environmental. The onset of the younger dryas, a rapid return to glacial conditions, would have transformed the landscapes they knew. Grasslands might have given way to tundra or scrub, altering the availability of food and water. Rivers could have shifted course or frozen over longer each year. A mobile hunting culture thrives on predictability in migration routes and seasonal patterns. When those patterns break, survival gets harder. And then there's the more dramatic possibility that the Clovis were caught in the crossfire of a planetary catastrophe. Proponents of the younger Dryas impact hypothesis note that the Clovis disappear right at the same moment the black mat layer appears across North America. If a comet or asteroid fragmented in the atmosphere, triggering wildfires, climate cooling, and ecosystem collapse, the Clovis might have been among its cultural casualties. The archaeological record offers tantalizing clues. At Murray Springs in Arizona, Clovis artifacts lie directly beneath the black mat, as though someone had closed the book on their way of life in a single season. At other sites, burned mammoth bones mingle with layers rich in soot and microspherules, signatures of intense heat. Not everyone agrees. Many archaeologists see the Clovis disappearance not as extinction, but as transformation. The people didn't die out. They merged with other groups, intermarried, and passed on parts of their knowledge. Some genetic studies suggest continuity between Clovis-era populations and later indigenous peoples supporting the idea that Clovis was a technology, not a tribe, and technologies can change faster than people do. But the allure of their sudden disappearance remains. We know their points. We know their campsites. We know the animals they hunted and the foods they gathered. What we don't know is what it felt like to stand in their shoes at the moment the old world ended. Imagine being a young hunter in a Clovis band. You've grown up watching the elders chip flint into elegant points, hearing the satisfying ping as flakes fall away. You've tracked mammoths across snowy plains, learned how to find water in the dry months, memorized the stars that guide your migration. And then one year, everything shifts. The herds you count on fail to appear. The rivers run lower or freeze longer. Smoke darkens the sky for weeks at a time. Around the fire, the elders argue. Some want to follow the animals farther than before into unknown lands. Others suggest hunting deer rabbits or birds instead. Someone mentions a band to the east who use smaller points, easier to make better for quick kills on smaller prey. You watch as the old ways clash with the new, the flint-napping rhythms changing, the elegant Clovis points giving way to something different. By the time your children are grown, the Clovis points are gone. The knowledge isn't entirely lost. It's absorbed into a broader survival strategy. But the identity tied to them fades like smoke carried off on the wind. To modernize, the Clovis story is a reminder that cultures can be both enduring and fragile. A technology can spread across a continent, thrive for centuries, and still vanish in less than a generation. Sometimes the cause is slow erosion, a gradual shift in resources and habits. Sometimes it's an abrupt break, and sometimes it's both. If you're holding a Clovis point now in a museum or a private collection, you're touching one of the last echoes of a vanished way of life. The stone is cold, but the edges are still sharp enough to cut. It's a whisper from the deep past, a reminder that nothing, even the most successful continent-spanning culture, is immune to change. Somewhere, under layers of soil and time, there may still be a campsite no archaeologist has found. A place where the last Clovis hunters sharpened their points, traded stories, and planned for a hunt that would never happen. A place where just beyond the firelight, the world they knew was already slipping away. At first you think it's just a dark patch in the tundra, the way the summer sun melts unevenly across the permafrost. But then you realize the ground isn't sinking, it's missing. A jagged hole yawns before you, its rim scalloped and raw, the earth around it thrown outward in a rough halo. It looks like something punched up from below, tearing through the frozen crust. This is the Siberian Yamal Peninsula, one of the most remote landscapes on Earth, and yet even here, the ground itself is starting to break apart in ways no one has seen before. The locals call them the mouths of the Earth. To scientists, they're explosive permafrost craters. Some of these holes are enormous, 30 meters across, plunging as deep as a 10-story building. The walls are slick with thawing ice, revealing cross-sections of frozen soil that have been locked away for tens of thousands of years. At the bottom, You can sometimes see a pool of icy water catching the pale Arctic light. The story of how they form begins deep underground, where permafrost soil and sediment frozen solid for millennia traps not just ice but gas. In this case, methane. During the last ice age, plants and animals were buried in silt and frozen before they could decay completely. Over tens of thousands of years, microbes trapped in the permafrost slowly broke down this organic matter, producing methane as a byproduct. The gas stayed locked away, unable to escape through the frozen cap above it. But the Arctic is warming faster than almost anywhere else on the planet. As the surface thaws, the frozen seal weakens. In some places, pockets of methane build up under pressure. When the pressure becomes too great, the cap of permafrost above bursts violently. The explosion throws soil, ice, and rock outward, leaving behind the gaping craters you see today. Scientists have measured methane concentrations inside these craters dozens of times higher than normal background levels. Satellite imagery shows that some craters were preceded by subtle bulges in the ground domes of swelling Earth, where gas was pushing upward before the blowout. It's tempting to see these craters as purely modern phenomena, a symptom of our changing climate. But some researchers wonder whether similar explosions might have occurred in the distant past, perhaps even during the Ice Age itself, when warmer intervals briefly thawed the permafrost. Could such events have played a role in shaping local landscapes, even in ways we don't recognize today? If you stand at the edge of a fresh crater, the scale is unnerving. The edges crumble underfoot, and the air coming from below is cold, but carries a faintly sweet chemical tang. You can see layers of history in the ice bands of sediment from summers long gone, each one a thin memory of a warmer season. Somewhere in those layers might be the pollen of ancient plants, the hairs of extinct animals, even microbes that have been asleep since mammoths roamed nearby. For indigenous Nenets reindeer herders, these craters are more than geological oddities. Some see them as omen signs that the land itself is unsettled. Practical concerns are also growing. The explosions are unpredictable, and a blast under a migration route or near a settlement could be deadly. And there's another layer of concern. Methane is a potent greenhouse gas trapping heat in the atmosphere far more effectively than carbon dioxide. Each crater is not just a scar, it's a release valve, sending ancient carbon into the modern sky. As more permafrost thaws, more of these blowouts could follow, creating a feedback loop where warming leads to more methane release, which leads to more warming. The Yamal craters are not alone. Similar features, though often smaller, have been reported in Alaska, Canada, and even the Tibetan Plateau. In some cases, the explosions happen underwater, where the gas escapes in great shimmering plumes. You can imagine the ancient equivalent. During a warmer interlude in the Ice Age, permafrost near the Arctic coasts could have thawed just enough for methane to build up and escape explosively. A hunter passing through might hear a deep muffled boom and feel the ground tremble, then later find a fresh, steaming pit in the tundra. Without modern science, What would you think? A giant had struck the earth with its fist. A spirit had torn open a doorway. In the modern world, scientists approach these features with drone sensors and sampling kits. They map the craters in 3D, measure the gas composition, and date the exposed ice layers. But there's still so much they don't know exactly how long the buildup takes, what triggers the final rupture, and how widespread the phenomenon could become as the Arctic continues to warm. One thing is certain, these craters are reminders that the ground beneath our feet is not always stable, especially in a warming world. The Ice Age may have locked away ancient air, but it didn't erase it. And now, those trapped gases are finding their way out sometimes with a bang. Standing here, you realize that in the span of a single human lifetime, landscapes we thought were eternal can change in an instant. The tundra feels timeless, but it isn't. It's just been holding its breath for a very, very long time. And now the exhale has begun. The wind here never really stops. It sweeps in from the north, carrying the dry, salty breath of the Arctic Ocean, rattling the low shrubs, and sweeping over a land that doesn't seem to end. But you're not on the Siberian coast, and you're not in Alaska either. You're somewhere in between a place that no longer exists. This was Beringia. During the last ice age, so much water was locked up in glaciers that global sea levels dropped by over 120 meters. What's now the Bering Strait, just 85 kilometers wide at its narrowest, was dry land. But Beringia wasn't just a narrow bridge. It was a vast, sprawling expanse stretching from the Kolyma River in Siberia all the way to the Mackenzie River in Canada. At its peak, it covered more than 1.6 million square kilometers, an area larger than modern-day Mexico. It wasn't barren either. This wasn't an icy wasteland, but a cold, dry grassland, the Mammoth steppe. Herds of caribou horses and bison grazed here, shadowed by wolves, lions, and humans. Stunted willows and dwarf birches grew in sheltered valleys, and in summer wildflowers dotted the plains. For thousands of years, Beringia was a crossroads, a place where Asia met the Americas, where animals and people moved back and forth. The people who lived here are at the center of one of archaeology's biggest debates. The Beringian standstill hypothesis proposes that a group of humans migrated from Siberia into Beringia more than 20,000 years ago, only to find their way south into the Americas, blocked by massive ice sheets. Trapped between the glaciers to the east and the harsher cold of Siberia to the west, they may have lived here in isolation for millennia, adapting to the environment and developing distinct genetic markers. Genetic studies of modern indigenous peoples in the Americas reveal a unique combination of DNA sequences that seem to have originated during this standstill. It's as if, in the long pause before moving on, Beringia became a kind of genetic workshop shaping the population that would eventually spread across 2 continents. Life here wasn't easy. Winters were long and brutal, with temperatures plunging far below freezing. Food came from the hunt caribou in the open grasslands, hares and birds, in the brushfish in the rivers. In summer, swarms of insects made life miserable, but also signaled the arrival of migratory birds, and the short-lived burst of plant growth. People built shelters from driftwood and mammoth bones insulated with hides and used fire to fend off the dark. The route southward into the Americas was eventually opened, but when and how is still hotly debated. For years, the prevailing view was that people crossed Beringia into Alaska and then traveled south through an ice-free corridor between the Laurentide and Cordilleran ice sheets around 13,000 years ago. But new evidence complicates that picture. Sites like Monte Verde in Chile, dated to at least 14,500 years ago, and the White Sands footprints in New Mexico, possibly over 20,000 years old, suggest that people may have reached the Americas earlier, perhaps by following the Pacific coastline in boats or on foot along kelp-rich shorelines. If that's true, then Beringia may have been more than just a waiting room. It could have been the launch pad for multiple migration waves, some hugging the coast, others moving inland later. Underwater archaeology is beginning to explore this lost world. When the glaciers melted and sea levels rose, Beringia was swallowed by the ocean, erasing most of the archaeological evidence. But sonar surveys and seabed sampling have begun to reveal drowned river valleys, ancient shorelines, and even places where freshwater springs still bubble up from what was once dry land. Somewhere out there beneath 50 meters of cold seawater might lie the remains of campsites' hearths and tools that could rewrite the story of the peopling of the Americas. The disappearance of Beringia wasn't just a loss of land, it was the end of a way of life. As the ice sheets retreated and the ocean rose, the vast steppe was cut in two. People and animals that once roamed freely between continents found themselves separated by water. Over time, cultures diverged, species evolved along different paths, and the memory of that open land became something you could only walk in your dreams. Still echoes of Beringia remain. Indigenous oral histories from Alaska and Siberia tell of lands to the east or west where the ground was firm and the hunting good. Genetic links between peoples on both sides of the Bering Strait speak to an ancient connection, one that even the rising seas couldn't sever entirely. Standing here, standing in what would have been here, you can almost see it. The endless grass rippling under a pale Arctic sun, mammoths moving slowly across the horizon, a line of hunters following at a distance. The air smells faintly of salt from the distant shore, but mostly it smells of grass and earth, a smell now trapped under meters of water. In a way, Beringia was the Ice Age's great highway and great cul-de-sac all at once. It was a place of movement and of waiting, of survival and transformation. It connected worlds, and then just as quickly, it vanished beneath the waves, leaving only the faintest traces for us to find. And somewhere out there, under the cold gray waters of the Bering Strait, the camps, the fires, and the footprints still sleep, waiting for the day the sea gives them back. It starts with something so ordinary you could almost step on it without noticing a shallow depression in soft ground filled with rainwater, maybe a scattering of leaves. But then you realize it's not just a hollow, it's a footprint wide at the heel, narrowing at the arch, spreading out at the toes. And there's another, and another. In the gypsum-rich flats of White Sands National Park, New Mexico, these footprints crisscross the ancient landscape in looping trails. Some are deep and sharp, others faint and worn like whispers of movement. They don't belong to modern hikers. They were left around 23,000 years ago during the Ice Age, when this was the shore of a great lake now long vanished. The preservation is extraordinary. The tracks were pressed into wet mud, then quickly covered with layers of sediment and hardened by the mineral-rich water. Over millennia, wind and erosion slowly exposed them again. Today, you can walk beside them and feel as though you're pacing the ancient world step for step. What makes these footprints so remarkable is not just their age, but what they imply. For decades, the prevailing theory was that humans entered the Americas no earlier than about 13,000 years ago, following an ice-free corridor after the last glacial maximum. Sites like Monte Verde in Chile and Bluefish Caves in Canada pushed that date back slightly. But there was still skepticism. White Sands blows that timeline wide open. The dating comes from seeds of the aquatic plant Ruppia serosa, found embedded in the same layers as the prints. Radiocarbon testing places them firmly in the middle of the last ice age thousands of years before the supposed opening of the ice-free corridor. If the dates are correct, it means humans were in North America during a time when vast ice sheets blocked the way south from Alaska, suggesting they must have arrived by another route, most likely along the Pacific coast. And it's not just one or two footprints. There are thousands spread across multiple sites in the park. They include the tracks of adults, teenagers, and even children, some walking purposefully, others wandering or zigzagging. In a few areas, you can see the overlapping impressions of humans and Ice Age animals, mammoths, giant ground sloths, camels, dire wolves. In one haunting sequence, the prints of a child weave alongside a large sloth's path, the sloth pausing occasionally as if standing to sniff the air, wary of the small biped following it. The human footprints aren't the deep, powerful impressions of a sprint. They're measured, deliberate. Some show signs of people carrying heavy loads, likely food, firewood, or even children. Others suggest the pace of play, the light scattering steps of someone running, stopping, turning. These aren't just marks. They're moments. But as with all extraordinary discoveries, not everyone agrees. Critics point out that radiocarbon dating of aquatic plants can be skewed by the reservoir effect, where older carbon from groundwater makes the samples appear older than they are. Could the footprints be younger than the tests, suggest subsequent studies using different dating techniques and cross-referencing with other environmental data have strengthened the case for their Ice Age origin, but debates continue. Regardless of the exact year, these tracks offer something archaeology rarely does: a direct physical connection to individual lives. You can imagine the day they were made. The sun is high, the air dry and clear. The lake glitters at the horizon. People move along its shore, perhaps gathering plants or hunting small game. Mammoths graze in the distance, their shaggy shapes massive against the flat plain. Somewhere nearby, a sloth lumbers slowly, stopping now and then to rear up and watch the strange two-legged creatures who share its world. What's striking is the normalcy of it. These aren't the traces of a grand migration or a desperate escape. They're the marks of a day in the life steps, taken without any thought that they would last beyond the next rainstorm. Yet they've endured for tens of thousands of years, carrying across time a record of movement so ordinary it becomes profound. For indigenous peoples of the Americas, the idea that their ancestors have been here far longer than 13,000 years isn't surprising. Oral histories speak of deep roots in the land stories passed down across countless generations. For science, though, each footprint is a piece of evidence forcing a re-evaluation of when and how humans first arrived. It's humbling to realize that our own presence can leave such enduring marks. We think of footprints as fleeting, erased by the next wave or gust of wind. But under the right conditions, they can outlast empires, languages, and even entire species. As you walk alongside the white sands tracks, you can almost hear the faint sounds of that lost world, the soft squelch of wet mud under bare feet, the distant trumpeting of mammoths, the dry rustle of grass in the wind. You can picture the small dramas unfolding, someone tripping and catching themselves, someone else stopping to look back, a child skipping to keep up with an adult's longer stride. And then, just like the people who made them, you leave your own tracks in the dust. The difference is, yours will be gone by the next storm. Theirs will still be here, waiting for the next set of eyes to follow. Close your eyes and imagine standing on a shoreline, but not the one you know. The air is colder, sharper, and the sea stretches farther away than it does today. Between you and the distant surf is a wide grassy plain dotted with shallow lakes and winding rivers. Birds wheel overhead, and somewhere out on the horizon, smoke rises from a campfire. This was once land. Now it lies drowned beneath the waves. During the last ice age, so much of the planet's water was locked up in glaciers that global sea levels were more than 120 meters lower than today. Vast areas of what are now continental shelves, those shallow zones along the edges of continents, were dry land. And humans lived there. They hunted, fished, gathered plants, and told stories around fires on coasts that don't exist anymore. As the world warmed and the glaciers melted, the seas rose. Slowly, relentlessly, those coastal plains shrank rivers, cut deeper valleys, and islands became peninsulas before becoming islands again. For people living there, the change may have felt gradual, measured in the distance between the village and the shore. But over centuries, the transformation was absolute. Entire landscapes vanished beneath the ocean, taking with them the evidence of lives lived at the edge of the Ice Age world. One of the most famous examples is Doggerland, the lost country of the North Sea. 10,000 years ago, it connected Britain to mainland Europe. Rolling hills, marshes, and river valleys stretched from what is now eastern England to the coasts of Denmark and the Netherlands. Archaeologists believe it was rich in game and fish, a prime hunting ground for Mesolithic peoples. As the sea rose, Doggerland fragmented into low islands before disappearing entirely around 6000 BC. likely after a catastrophic tsunami triggered by the Storegga Slide, an enormous undersea landslide off the coast of Norway. Farther east, in Japan's Ryukyu Islands, divers explore the Yonaguni Monument, a submerged series of massive stone terraces and steps, some argue carved by human hands, before the rising sea swallowed them. Skeptics say the formations are natural, shaped by fracturing and erosion of sandstone. But even if Yonaguni is a geological oddity, the surrounding continental shelves almost certainly hold other, as yet undiscovered Ice Age sites. In the Arabian Sea, the Gulf of Cambay has revealed hints of a drowned prehistoric landscape. Sonar scans have mapped what appear to be regular rectilinear structures lying 40 meters below the surface, alongside stone tools dated to tens of thousands of years ago. The currents are strong, the water murky, and the site remains controversial. But if confirmed, it could be one of the oldest known urban areas on Earth. These examples are just a glimpse of what's been lost. By some estimates, up to 2/3 of the habitable land available to humans during the Ice Age is now underwater. The first fishing villages, the earliest coastal trade networks, the seasonal camps where hunters processed seals and seabirds, all of it erased from the visible map, hidden under silt and salt water. And yet hints still surface, sometimes literally. Storms occasionally dredge up ancient tools, bones or peat deposits from the seabed. Fishermen trawling the North Sea have pulled up reindeer antlers, mammoth tusks, and flint spear points. Off the coast of Florida, divers have found submerged sinkholes containing the remains of Ice Age animals and early humans. For archaeologists, the challenge of studying these drowned worlds is immense. Underwater excavation requires specialized equipment, and sites are vulnerable to erosion looting and modern construction. But advances in sonar mapping, remote-operated vehicles, and sediment analysis are beginning to reveal detailed images of the seafloor. In some cases, scientists can even reconstruct Ice Age coastlines, tracing the river systems and valleys that once guided human movement. It's not hard to see why Ice Age people would have favored the coasts. Shorelines offered abundant resources: fish, shellfish, seabirds, and marine mammals, along with fresh water from rivers and streams. Coastal routes also provided relatively easy travel compared to dense forests or mountainous terrain. Some researchers argue that the first humans in the Americas may have followed a kelp highway along the Pacific Rim, exploiting rich marine ecosystems from Asia to South America. If true, much of that journey's archaeological evidence is now underwater. Sites that could confirm the earliest coastal migrations are lying beneath layers of sand and sediment just offshore, waiting for the right technology and enough funding to find them. There's something haunting about these drowned landscapes. We tend to think of prehistory as landlocked, but the truth is that our ancestors were coastal people as much as they were inland wanderers. The rise of the sea erased not just villages and hunting grounds, but the places where some of humanity's earliest cultural and technological innovations may have occurred. Imagine for a moment standing on the last high ground of Doggerland as the waters creep closer each year. The shoreline where you once launched your fishing canoes is gone. The familiar paths to hunting grounds are underwater, and your children are born into a world that feels smaller with each passing season. You don't have maps to show what's happening, but you can see it, the horizon drawing closer, the ocean taking more than it gives. And yet the people didn't simply vanish. They adapted, moving inland, merging with other groups, carrying with them the skills and stories of the coast. Even today, fragments of those stories might survive in myths of great floods, sinking lands, and gods who once walked where the sea now lies. Somewhere out there, under tens of meters of water, is a hearth where someone once cooked the day's catch. The fire burned hot enough to crack the stones, and the ashes still lie in a small gray circle. The waves roll above it now, as they have for thousands of years. But the past doesn't go away. It just waits in the deep. The ice is endless. It stretches from the rocky shore out to the hazy horizon, broken only by jagged ridges, where the sea has buckled and frozen in place. You're standing at the edge of the Atlantic, except the Atlantic isn't a restless rolling ocean here. It's a frozen highway, a shifting sheet of ice that links one continent to another. This is the heart of the Solutrean hypothesis, one of archaeology's most controversial ideas. It suggests that during the height of the Ice Age, people from what is now Western Europe may have crossed the North Atlantic by following the southern edge of the polar ice. Instead of walking across a land bridge like Beringia, they might have paddled skin-covered boats between ice floes, hunting seals and seabirds, and eventually arriving on the shores of North America thousands of years before the Clovis culture appeared. The theory takes its name from the Solutrean culture, which flourished in France and Spain between about $22,000 and 17,000 years ago. Solutrean toolmakers were masters of stone flaking, producing elegant symmetrical points with a distinctive laurel leaf shape. These tools bear a tantalizing resemblance to some of the earliest fluted points found in North America, not identical, but similar enough to make some researchers wonder if the knowledge could have crossed the ocean along with the people. Proponents point to other pieces of circumstantial evidence. The Ice Age North Atlantic wasn't open water. From shore to shore, it was a patchwork of frozen fields and narrow leads, much like the Arctic Ocean today. Solutrean hunters were well adapted to cold climates and skilled at exploiting marine resources. It's not hard to imagine them traveling along the edge of the ice, hunting seals from kayaks or umiak-like boats, stopping at ice camps to rest and gradually moving westward. The journey would have been perilous, but over generations, families could have leapfrogged their way across. There's also the matter of the Cactus Hill site in Virginia, where artifacts dated to around 18,000, 20,000 years ago appear to predate Clovis technology by several millennia. Some see this as evidence of an earlier migration, perhaps by Solutrean voyagers. But the Solutrean hypothesis is far from accepted fact. Critics argue that similarities in tool styles can arise independently, a concept known as convergent evolution in technology. Two cultures solving the same problem making a sharp, strong hunting point in similar environments might arrive at similar designs without ever having met. Genetic evidence is another stumbling block. DNA from ancient North American remains overwhelmingly shows links to East Asian and Siberian populations consistent with a Beringian migration. So far, there's no definitive genetic signature connecting Ice Age Europeans to early Native Americans. And then there's the practical challenge. Crossing the glacial Atlantic would have been brutally dangerous. The cold could kill in minutes, storms could crush boats between ice floes, and food would be scarce in places. While Arctic peoples like the Inuit thrive in similar environments, today, their survival depends on technologies like advanced harpoons, insulated clothing, and dog sleds that we have no evidence the Solutreans possessed. Still, the hypothesis refuses to die. Partly because it's such a compelling mental image, hunters in fur-lined hoods gliding silently along an ice edge under a pale winter sun, watching for the plume of a seal's breath. Partly because it forces us to reconsider how flexible and adventurous Ice Age humans might have been. Even if the Solutrean hypothesis is wrong in its specifics, it underscores a broader point. The people of the Ice Age were not limited to land routes. They were capable of exploiting coastal and marine environments in ways we're only beginning to appreciate. The same skills that allowed humans to cross from island to island in the Pacific could have been applied in cold water settings, pushing into new frontiers long before the historical age of exploration. Imagine being one of those voyagers, whether Solutrean or from some other now forgotten culture. You set out from a familiar headland, paddling into a maze of ice and open leads. The wind is sharp, the light flat, and blinding against the snow. You know the direction you must travel, not because of maps, but because of the sun's arc, the stars, and the memory of the last elder who made the journey. Days pass. You haul your boat onto an ice floe to rest, building a small windbreak from blocks of snow. At night, the aurora ripples overhead, and the ice groans with the shifting tide beneath it. Weeks later, you spot a distant coastline, low and dark against the white horizon. Birds circle above it, and you can smell the faint, earthy scent of land. You don't know it yet, but you've reached a continent no one in your people has ever seen. Behind you lies an ocean that will eventually erase your route from memory. Ahead lies a world of unfamiliar animals, rivers, and forests, and perhaps other humans. Whether or not the Solutrean crossing happened, it's clear that humans have been reaching new lands in improbable ways for tens of thousands of years. The Pacific Islands, Australia, and even the Arctic show us that distance and danger were not absolute barriers. The Ice Age was full of challenges, but it was also full of pathways, some on land, some on ice, and some across open water, and somewhere beneath the waves of the North Atlantic, or buried under silt along a forgotten shoreline, there might still be the remains of a campfire, a stone point, or a bone harpoon waiting to tell the story of a journey we've only imagined. You hear it before you see it, a deep, steady roar That's not quite thunder and not quite wind. The air seems to hum, and then as you crest a ridge, the horizon splits open in a long, jagged line of white. It's not snow, it's water. Before you stretches an ice-dammed lake so vast it swallows the landscape. This is Glacial Lake Agassiz, one of the largest freshwater bodies in Earth's history. At its peak, it covered more area than all of the modern Great Lakes combined, over 400,000 square kilometers, stretching across what is now Manitoba, Ontario, Saskatchewan, North Dakota, and Minnesota. Standing on its shore during the Ice Age, you'd see not a placid blue expanse, but a restless slate-colored sheet flecked with icebergs calved from the glacier wall that forms its northern edge. Lakes like Agassiz weren't rare during the last glacial period. As the massive Laurentide ice sheet advanced and retreated, meltwater pooled at its edges, trapped by ridges of ice or sediment. These lakes could last for centuries, growing slowly, or they could collapse in days, unleashing floods so massive they rewrote the map. The end of Lake Agassiz was one such moment. Around 12,900 years ago, right at the onset of the Younger Dryas, a colossal outburst flood may have occurred when its southern or eastern ice dam failed. Imagine billions of tons of water surging across the land, carving valleys, moving boulders the size of houses, and scouring the landscape bare. The flow would have been more powerful than all the rivers on Earth combined, racing toward the North Atlantic. This sudden pulse of fresh water is one leading theory for the Younger Dryas cooling. By dumping so much fresh water into the ocean, the flood could have disrupted the Atlantic meridional overturning circulation, the great conveyor belt that moves warm, salty water northward. Without that heat, the northern hemisphere would have plunged back into Ice Age conditions for over 1,000 years. But the story doesn't end there. Geological evidence shows that Lake Agassiz didn't drain just once. It emptied and refilled multiple times over thousands of years. Each time the landscape downstream was transformed. In the Pacific Northwest, for example, a similar ice-dammed lake, Glacial Lake Missoula, burst at least 40 times, sending walls of water racing across eastern Washington and creating the scoured canyons of the channeled scablands. For anyone living near these lakes, the danger would have been unimaginable. You might hear a distant cracking, like the earth splitting open, and feel a sudden tremor under your feet. Minutes later, a wall of water hundreds of feet high would appear on the horizon, carrying chunks of ice trees and debris roaring forward faster than a horse could run. There would be no outrunning it, only the brief hope of reaching high ground before it arrived. Indigenous oral traditions from North America may preserve memories of such floods. Stories of great deluges, sudden rising waters, and lands swallowed overnight are found among many cultures. While not all can be tied to glacial lake outbursts, some details, such as references to floating ice or specific valleys, are strikingly consistent with geological evidence. Scientists study these ancient floods, not just for what they reveal about the past, but for what they warn about the future. Today, smaller ice-dammed lakes in places like Alaska, the Himalayas, and the Andes still pose risks to communities downstream. known as Glacial Lake, outburst floods, GOFs. They can destroy villages and infrastructure in minutes. And as modern glaciers retreat, the number and size of such lakes are increasing. But during the Ice Age, the stakes were on a planetary scale. The release of Lake Agassiz's water may have been a tipping point for the climate, demonstrating how a single event in one region can ripple across the globe. It's a reminder that the Earth system's ice-water atmosphere are interconnected in ways that can amplify both disaster and recovery. Picture standing on a bluff as the last of Lake Agassiz drains. The roar fades, leaving behind a silence so profound it feels physical. Where water once stretched to the horizon, you now see mudflats, stranded icebergs melting under the sun, and the exposed skeletons of fish. In the distance, the glacier still looms, its blue face cracked and groaning. You know it will melt again, and the lake will return, but perhaps not in your lifetime. Over thousands of years, the former lakebed will transform. Grasses and shrubs will take root. Rivers will find new courses through its flat expanse. Eventually, it will become home to forests, prairies, and human communities. But the land will never forget. Buried in its soils will be layers of silt pollen and fossilized shells that tell the story of when this place was an inland sea, and when it vanished in a matter of days. Lake Agassiz and its kindred waters were Ice Age giants, as much a part of the glacial landscape as the mammoths and mastodons. They were temporary by nature, but their impacts were permanent, shaping valleys, influencing climate, and leaving behind mysteries we're still piecing together. And somewhere out there, beneath the farmlands of Manitoba or the forests of Ontario, the ancient shoreline is still visible if you know how to look a gentle rise in the land, curving like the ghost of a wave that once stood taller than a mountain. The air is still, but there's a heaviness to it, the kind you feel just before a storm. The ground beneath your boots is damp and dark, not from recent rain, but from something deeper water that has been here for thousands of years. You're standing at the edge of a bog, a place where the past doesn't just linger in memory. Here, it's preserved in flesh and bone. Bogs are nature's time capsules. Their water is acidic, low in oxygen, and often rich in sphagnum moss, which releases compounds that slow decay. In most environments, organic material wood, leather, skin rots away within decades. In a bog, it can last for millennia. During the Ice Age, and after these wetlands quietly swallowed and sealed whatever entered them, whether it was a fallen tree, an animal, or a human being. Across northern Europe, bogs have given up astonishing relics of the distant past. The Tolland man in Denmark, the Lindo man in England, the Weed girl in the Netherlands. These are not skeletons bleached by time, but individuals so well preserved that their hair fingerprints and even last meals remain. Their skin is darkened and leathery, but their faces are still recognizable sometimes, with expressions frozen in place. Most famous bog bodies date to the Iron Age, but bogs existed long before that. An Ice Age finds, though rarer, are equally striking. In Ireland, Pieces of worked wood and animal bone from more than 10,000 years ago have been pulled from peat. In Germany's Schöningen, bog wooden spears over 300,000 years old were discovered, the oldest known complete hunting weapons. In Siberia, entire Ice Age animals, horses, bison, even a baby woolly rhinoceros have been found in permafrost-rich bogs, their fur still clinging to their hides. One of the most haunting aspects of bog preservation is how it collapses time. You can stand over a body or artifact and realize that it looks almost as it did on the day it entered the water. A carved spear handle still bears the marks of its maker's tools. A scrap of hide still holds the imprint of the sewing stitches. The line between long ago and just yesterday blurs in a way that feels almost unsettling. But bogs also hold mysteries. Many human bog bodies show signs of violent deaths, strangulation, stabbing blows to the head. Were they victims of crime execution or ritual sacrifice? The Ice Age may have had its own versions of these events, but without written records, we can only guess. In an Ice Age context, bogs were often important resource zones. They provided water-edible plants and animals to hunt, but they could also be dangerous. The soft, quaking surface might conceal deep pools where a misstep could be fatal. It's easy to imagine a hunter crossing a wetland on a foggy morning, his foot slipping into an unseen hollow, the peat closing over him before anyone could pull him free. And sometimes, people might have come here on purpose to leave something behind. Archaeologists have found caches of tools, weapons, and ornaments deliberately deposited in wetlands, possibly as offerings. The reflective surface of the water, the stillness of the place, and the way it swallowed objects whole could have given bogs a spiritual significance, doorways to another world perhaps. In the far north, the preservation power of wetlands merges with that of permafrost, creating conditions so perfect that the Ice Age can reach across time almost untouched. In 2018, researchers in Yakutia discovered a 40,000-year-old foal in a permafrost bog, its mane tail, and even the contents of its stomach intact. In another case, a pair of prehistoric puppies emerged from the frozen peat, their fur and whiskers still in place after more than 12,000 years. Imagine finding such a thing yourself. You're slogging through the edge of a bog, your boots sinking into the spongy ground, when you see something pale jutting from the peat. At first you think it's a root, then maybe a bone. As you scrape away the moss, a shape emerges, a hoof, a leg, and then the whole small body of a creature that last breathed when mammoths walked nearby. Its eyelashes are still there. The air smells faintly sweet and earthy, like a forest floor after rain. Bogs don't just preserve the physical, they preserve moments. A pollen grain trapped in the peat can tell you what plants were blooming the year it fell. Layers of moss record centuries of climate data, with each stratum representing a growing season. In some cases, even ancient footprints pressed into the bog surface have survived, filled in, and sealed by new growth before they could collapse. For scientists, bogs are libraries without books. Core samples drawn from their depths can reveal changes in vegetation rainfall and temperature going back tens of thousands of years. That means they're not just places of eerie discovery, they're vital records of the Ice Age environment. and yet they're fragile. Draining a bog for farming or development exposes its contents to oxygen, starting the clock on decay. What lasted millennia in the dark, wet stillness can crumble in weeks once exposed to the air. Every find is a race between preservation and loss. Standing at the edge of a bog, you can see why they've inspired both reverence and fear. The water is still enough to reflect the sky perfectly, but the surface quivers under the lightest touch. It's beautiful and unsettling all at once, a place where the world above and the world below meet, and where the past can rise without warning. Maybe that's the most remarkable thing about bogs. They remind us that the Ice Age isn't gone. It's waiting under our feet, wrapped in peat and moss, patient and unhurried. And when it's ready, it will hand us something from its keeping: a spear, a skull, a whole creature, so we can remember what the world once was. The first thing you notice is the smell, a faint mineral tang like rain hitting hot stone. You're standing inside a cavern, and the air feels older here, heavier. Your flashlight beam dances across walls that ripple with strange undulating shapes. At first you think they're just mineral deposits, but then you see the edges sharp, precise, deliberate. These are carvings, and they were made by hands tens of thousands of years ago. Ice Age caves are not just holes in the ground. They are time machines. They were places of shelter, yes, but also of ceremony, art, and memory. In some, you find paintings so vivid they could have been finished yesterday. Herds of bison charging across the walls, mammoths with their shaggy outlines, horses mid-gallop, and strange abstract symbols whose meanings are lost to us. One of the most famous is Chauvet Cave in southern France. Sealed by a rockfall for over 20,000 years, it contains more than 1,000 images painted with charcoal and red ochre. Lions stalk aurochs across the limestone panels, while rhinos clash horn to horn in the flickering light of what would have been small, smoky fires. The artists understood movement lines overlap to suggest the lift of a hoof, the turn of a head. These were not crude doodles. They were deliberate acts of storytelling. Farther north, in Spain's Altamira Cave, the ceilings are alive with polychrome bison. In Indonesia's Liang Tedonge Cave, hand stencils and wild pig paintings date back over 45,000 years, showing that Ice Age art was not confined to Europe. Across the world, in regions where limestone or volcanic rock offered shelter, humans left marks meant to outlast them. The act of painting or carving deep underground was no casual pastime. Caves can be treacherous, twisting passages, narrow squeezes, sudden drops. In the Ice Age, reaching the inner chambers often meant crawling by firelight, carrying torches that smoked and sputtered, navigating by memory and touch. Some images are placed in locations so difficult to reach that it's clear the act of making them was as important as the finished work. What drove these people to decorate the darkness? Some theories are practical. Perhaps the art was a way of recording hunts, teaching young hunters about animal behavior, or marking territory. Others see it as spiritual part of rituals, meant to ensure a successful hunt or honor the spirits of the animals. The placement of certain animals in deep echoing chambers suggests that sound may have been part of the experience. Imagine chanting or drumming in a place where the walls themselves seem to join in. There's also the possibility that some images were not meant to be seen by everyone. In some cultures, sacred knowledge is shared only with initiates. The remoteness of certain cave paintings could mean they were part of rites of passage, where the journey into the cave mirrored a symbolic journey into another realm. Ice Age caves weren't just canvases, they were archives. Archaeologists have found torch marks, stone tool fragments, and even footprints on the cave floors. In the Chauvet Cave, the prints of a child walking alongside a wolf or large dog-like canid have been preserved in the soft clay for over 20 millennia. Were they companions? Was the wolf tamed? Or was it simply following historians still debate? Some caves tell a story that spans thousands of years. At Lascaux, in France, layers of art suggest that generations return to the same site, adding new images while respecting the older ones. This continuity hints at cultural traditions strong enough to survive changes in climate prey and even population movements. And it's not all animals. Abstract signs, dots, zigzags, ladder-like shapes appear repeatedly across sites separated by thousands of kilometers. Researcher Genevieve von Petzinger has cataloged dozens of these recurring symbols, suggesting that they may represent a kind of proto-writing, a shared symbolic language long before the first alphabets. What's perhaps most astonishing is how fragile all this is. The moment a sealed cave is open to modern air, the balance that preserved its art begins to shift. Mold algae and microscopic crystals can bloom on the walls, fed by changes in humidity and the presence of human visitors. Lascaux had to be closed to the public in 1963 after such damage began, and today, most famous cave art is studied using 3D scans and virtual models rather than direct visits. But that doesn't diminish their power. Even on a screen, the sight of a mammoth drawn by someone who lived 30,000 years ago hits you in a way that statistics and dates cannot. You're looking at the work of a person, not an abstract Ice Age human, but an individual, someone with skill, patience, and a vision of what they wanted to put into the world. Imagine being there when the paint was still wet. The chamber is lit by flickering firelight, the walls alive with shadows. The artist leans close to the rock, blowing pigment through a hollow bone to create a soft edge on a bison's flank. Others sit nearby, watching in silence, the smell of smoke and ochre heavy in the air. Somewhere in the distance, water drips steadily from the ceiling. When the artist steps back, the bison seems to move in the shifting light. That moment is long gone, but the bison remains waiting in the dark for the next light to fall upon it. And in that light, the thousands of years between you and the artist vanish for just a heartbeat. The caves of the Ice Age are proof that humans have always needed to create, not just for survival, but for meaning. They remind us that even in a world of cold and scarcity, there was time for beauty, for abstraction, for something beyond the immediate needs of the day. In the end, those marks on the wall are more than art. They're a message. We were here. We saw. We imagined. It begins with a roar so low you feel it in your chest before you hear it with your ears. Then the sound builds, deep rumbling, unstoppable, until it becomes a wall of noise, the kind that drowns out thought. Ahead of you, an enormous sheet of ice begins to move. You are watching a glacier surge. During the Ice Age, glaciers weren't the static frozen landscapes we sometimes imagine from postcards. They were dynamic rivers of ice constantly shifting, grinding, and reshaping the land beneath them. Over decades or centuries, most glaciers moved slowly, creeping forward at mere inches per day. But sometimes they surged, lurching forward at speeds of dozens of feet per day, bulldozing everything in their path. A surge is a kind of glacial tantrum, and the reasons behind it are still not fully understood. One cause may be the buildup of meltwater at the base of the glacier, reducing friction and allowing the ice to slide more rapidly over the ground. Another may involve shifts in the glacier's internal structure as layers of ice deform and collapse under their own immense weight. Whatever the cause, the effect is, dramatic valleys are scoured, clean rivers are dammed, and massive piles of rock and debris moraines are left behind as the glacier retreats again. Ice Age glaciers were colossal. The Laurentide ice sheet, which covered most of Canada and parts of the northern United States, was up to 2 miles thick in places. In Eurasia, the Fennoscandian ice sheet sprawled across Scandinavia, northern Europe, and western Russia. Together, these ice sheets locked up so much water that sea levels dropped by over 120 meters. The landscapes they left behind are all around us, even if we don't always recognize them. U-shaped valleys, carved by glaciers, stand in stark contrast to the V-shaped valleys made by rivers. Fjords, those deep, narrow inlets framed by towering cliffs, are drowned glacial valleys created when the ice retreated and the sea flooded in. Erratics, enormous boulders that seem out of place in their surroundings, were plucked from one location and deposited miles away by moving ice. But glaciers weren't just destructive. They were also life-giving. As they ground over the bedrock, they crushed it into fine particles known as glacial flour. Carried away by meltwater, this mineral-rich dust fertilized distant lands, boosting plant growth and supporting rich ecosystems. Even today, some of the world's most fertile soils, like those of the North American prairies and European plains, owe their productivity to Ice Age glaciers. For humans, glaciers were both barriers and resources. A vast ice sheet could block migration routes, forcing people to detour hundreds of miles or wait centuries for the ice to retreat. But glaciers also fed rivers, created seasonal meltwater lakes, and provided ice for storage or cooling. In mountainous regions, glaciers could be used as natural highways, their smooth, frozen surfaces easier to traverse in winter than rocky terrain. There's evidence that Ice Age peoples adapted ingeniously to these frozen giants. In the Alps, archaeological finds suggest that people hunted ibex and chamois along glacier edges, taking advantage of the animals' predictable movements. In North America, Early humans may have used glacial corridors to move between regions, timing their journeys to avoid dangerous crevasses or unstable ice. And then there's the other side of the story, when glaciers melted too fast. At the end of the Ice Age, retreating ice sheets unleashed enormous volumes of water, triggering floods, landslides, and sea level rise. We've already seen what happened when ice-dammed lakes like Agassiz burst. But even without a dramatic dam failure, steady melting transformed coastlines and drowned river valleys, forcing human and animal populations to adapt or move. The retreat of glaciers also revealed land that had been buried for tens of thousands of years. In Alaska and Siberia, melting ice exposed the carcasses of mammoths, woolly rhinos, and other Ice Age animals, their bodies so well preserved that even stomach contents remained. These finds have provided priceless insights into Ice Age ecosystems and, in some cases, fueled speculative dreams of cloning extinct species. For indigenous peoples in glaciated regions, glaciers weren't just physical features. They were woven into cosmology and oral tradition. In the Pacific Northwest, stories speak of battles between ice and fire, or of glaciers as living beings that could advance or retreat in response to human actions. Such stories often carried practical knowledge too, warning of the dangers of traveling on unstable ice or settling in flood-prone valleys. Standing at the snout of a modern glacier, you can still feel some of the awe that Ice Age humans must have felt. The air is cooler here, tinged with the scent of wet stone. Meltwater streams gush from tunnels beneath the ice, carrying pebbles and silt. Every few minutes, a cracking echo rolls through the valley as ice shifts deep within. You are standing at the boundary between two worlds, the frozen one that shaped the past and the thawed one we inhabit now. And just as in the Ice Age, glaciers remain both fragile and powerful. Around the world today, they are shrinking at unprecedented rates. Their retreat is exposing landscapes that haven't seen daylight in thousands of years and releasing ancient air pollen and microbes trapped within. While the glaciers of our time are smaller than the giants of the Ice Age, their disappearance will still have profound effects, from rising seas to changes in river flow that could alter entire ecosystems. In that sense, we are living through a transformation not unlike the one that ended the last Ice Age. The difference is that now we can watch it unfold in real time, and perhaps learn from the lessons carved into the valleys and moraines the glaciers left behind. If you listen closely, you might even hear the echoes of that ancient roar carried faintly on the wind, a reminder that the ice is never truly still and that its story is still being written. It starts with a crack, not a gentle one, like a tree branch breaking in the wind, but a sharp, gut-deep sound that ricochets across the valley. Then another, and another. The ice is talking. You're standing at the foot of a frozen wall, the face of a glacier, and in front of you an iceberg the size of an apartment building is about to be born. This is calving, the moment when a chunk of ice breaks free from the glacier, or an ice shelf, and crashes into the sea or a lake. In the Ice Age, this sound would have been as common in coastal zones as the crash of waves nature's own cannon fire. We tend to think of icebergs as lonely drifters, but they begin life as part of a much larger story. In the Ice Age, many glaciers didn't just stop on land, they pushed out into the sea, forming massive floating extensions called ice shelves. These shelves were hundreds of feet thick, and as they crept forward, they fractured along deep cracks until great slabs broke away. The physics of calving is dramatic. When an iceberg detaches, the sudden change in balance can send it rolling, flipping, or plunging below the surface before bobbing back up. Waves radiate outward, carrying ice chunks and foam. In enclosed bays or fjords, these waves can swamp shorelines, washing away anything too close to the water. Imagine being an Ice Age hunter in a skin boat scanning the ice front for seals, only to be caught by a wave from a collapse half a mile away. The icebergs that drifted away from these events were not small. Some were the size of cities, towering high above the waterline and stretching deep below it. Remember, only about 1/10 of an iceberg's mass is visible above the surface. The rest is hidden beneath the waves. A pale blue-green mountain of ice grinding slowly through the water. In the North Atlantic during the Ice Age, these icebergs carried more than just frozen water. As glaciers scraped over land, they picked up rocks, gravel, and sediment, which became embedded in the ice. When the bergs eventually melted far from their source, they dropped this material onto the seafloor. Today, scientists use these ice-rafted debris deposits in ocean sediments to map ancient iceberg routes and track the pulses of ice sheet collapse known as Heinrich events. Heinrich events were particularly massive episodes of iceberg calving when armadas of icebergs flooded the North Atlantic, sometimes covering areas larger than modern Europe. The release of so much fresh water into the ocean likely disrupted currents, altered climate patterns, and may have triggered colder periods in the Ice Age cycle. They were not one-off disasters, they happened repeatedly, perhaps every few thousand years. For people living along Ice Age coasts, these events must have been both terrifying and awe-inspiring. The sudden appearance of dozens or hundreds of towering bergs drifting offshore would have transformed the seascape overnight. Some might have been close enough to hear the groans and cracks as they melted, or to smell the strange, clean scent of ancient ice releasing air that had been trapped for tens of thousands of years. Icebergs also created opportunities. In the right conditions, they were rich hunting grounds. Seals and seabirds rested on the ice, and fish gathered in the nutrient-rich waters stirred by melting. For a skilled hunter with a kayak or canoe, a small iceberg could be approached for a quick hunt. Though larger bergs were dangerous, prone to rolling or shedding chunks without warning. Even inland calving could be part of life. Proglacial lakes, bodies of meltwater trapped against a glacier, often had floating icebergs. In the Ice Age, Rockies, such lakes might have been dotted with ice year-round, breaking apart in spring with thunderous splashes. And then there's the human fascination with ice itself. Imagine chipping off a piece of an iceberg water, frozen centuries before you were born, and melting it to drink. It would be the purest water imaginable, untouched by soil or modern pollution. That experience repeated over generations could have built traditions, myths, even rituals around the ice. From a scientific point of view, icebergs are time capsules. Inside their frozen layers are tiny bubbles of ancient atmosphere, each one a miniature climate archive. When researchers drill into old ice today, they can measure greenhouse gas levels from the Ice Age, tracking how carbon dioxide and methane rose and fell alongside temperature shifts. While we don't have direct access to the icebergs of the past, we know from surviving glaciers and ice cores that they carried these same records as they drifted to their meltwater graves. If you were standing on an Ice Age cliff above the ocean during a calving event, you'd see more than just ice breaking apart. You'd be watching a climate system in motion. The calving front marks the place where the solid world of land and ice yields to the shifting liquid world of the sea. Every iceberg that falls is part of a cycle snow. To glacier, glacier, to sea, sea, to sky, sky, to snow again. That cycle is still with us, though the balance has shifted. Modern ice shelves in Greenland and Antarctica are calving faster than they did for most of the past 10,000 years. In some places, the process is accelerating beyond anything humans have seen before. The giants of the Ice Age may be gone, but their descendants are still breaking away, carrying echoes of those ancient crashes into the present. If you close your eyes and listen, you might hear it. The deep crack, the roar of water, the rolling boom as ice meets sea. Somewhere in your imagination, a wall of ice looms in the distance, and a slab the size of a city is teetering ready to fall. And when it does, the sound will follow you for the rest of your life. The air is sharp, brittle with cold, but your breath doesn't form the thick clouds you'd expect. That's because the wind is stealing it away before you can even see it. You're standing on a barren, windswept plain dotted with tufts of hardy grass and low shrubs. No trees, no shelter, just open space stretching to the horizon in every direction. This is the Mammoth Steppe. During the Ice Age, it was the largest biome on Earth, a belt of treeless grassland stretching from the Pyrenees in Western Europe across Siberia, over Beringia, and all the way into the Yukon and Alaska. It covered millions of square kilometers, a super ecosystem that dwarfed today's African savannas, and it was bursting with life. We call it the Mammoth Steppe for good reason. Here, herds of woolly mammoths trundled slowly across the grasslands, their shaggy coats rippling in the wind, their curved tusks gleaming in the low sun. Beside them moved woolly rhinoceroses, massive bison wild horses, and saiga antelope. Predators followed scimitar-toothed cats, cave lions, wolves, and hyenas. Even the occasional human band appeared along the edges, hunting, scavenging, or following the herds for days on end. The secret to this ecosystem's success was its vegetation. The steppe was a cold, dry grassland, not tundra, which is dominated by moss and lichen, but a mosaic of grasses, herbs, and nutrient-rich forbs. These plants were hardy, able to survive long, dark winters and rebound quickly in the short summer growing season. Their roots anchored the thin, permafrost-bound soil, and their seeds provided food for everything from rodents to giant grazers. It was in many ways the Ice Age's version of a buffet. Large herbivores could graze year-round, scraping away snow with their hooves or tusks to get at the plants beneath. Predators never had to look far for prey. Even scavengers like ravens and Arctic foxes thrived here. But the mammoth steppe wasn't uniform. In some areas, meltwater from seasonal thaw created wetlands buzzing with insects in summer and teeming with waterfowl. In others, low hills provided shelter from the wind, attracting animals in winter. River valleys cut across the plains, their edges lined with willow and birch scrub, offering both food and firewood for human visitors. For Ice Age people, the steppe was both a land of opportunity and a challenge. Game was abundant, but so was exposure. Without forests for shelter, hunters had to adapt. They wore thick hides, built windbreaks from snow and bone, and carried their fuel with them. Some groups constructed semi-permanent camps near reliable water sources, while others roamed with the herds, traveling light and fast. We know from archaeological finds that humans on the steppe were skilled at exploiting its resources. They hunted mammoths not just for meat, but for bones to build frameworks for shelters and tusks to carve tools and art. They followed seasonal migrations, timing their hunts to coincide with calving seasons or fat-rich autumn herds. In places like Siberia's Yana rhinoceros horn site, dating back over 30,000 years, people lived year-round at high latitudes crafting finely worked tools from stone, bone, and ivory. And then almost everywhere, the mammoth steppe vanished. Its decline was tied to the end of the Ice Age around 14,000 taus, 10,000 taus years ago. As the climate warmed, precipitation increased, and the vast grasslands began to transform into tundra in the north and forests in the south. Moss and shrubs replaced the grasses in many areas, offering less nutrition for the great grazers. As the vegetation changed, the large herbivores declined, and with them the predators and scavengers that relied on them. Some scientists argue that humans accelerated the collapse. By hunting mammoths and other keystone species to extinction, we may have removed the gardeners of the steppe, the animals whose grazing kept shrubs at bay and encouraged grass growth. Without them, the ecosystem shifted toward less productive plant communities. In recent years, researchers in Siberia have been trying to reverse this process in an experiment called Pleistocene Park. By reintroducing large grazers like bison musk oxen and horses into a fenced reserve, they hope to recreate the grazing pressure of the Ice Age steppe, compacting snow in winter, which helps keep permafrost frozen and maintaining grass dominance over shrubs. The ultimate dream: to bring back the woolly mammoth through genetic engineering and let it roam here once more. The mammoth steppe's disappearance is a reminder that even the largest, most resilient ecosystems can be fragile when key conditions change. It thrived for tens of thousands of years, supporting enormous populations of animals and humans, but within a few thousand years of the last glacial maximum, it was gone. If you could stand on one of its low hills at its peak, you'd see movement in every direction, herds stretching to the horizon, dark shapes of predators shadowing the edges, clouds of birds rising from wet meadows. The air would carry the musk of animals, the crunch of hooves on frozen ground, the distant crack of ice shifting on a river. And somewhere in the mix, the flicker of human fires, small but stubborn, holding their own in a world built for giants. Today, the closest you can get to that world is in the Arctic's remaining tundra steppe patches, where hardy grasses and dwarf willows cling to the wind-scoured soil. But the soil still holds the seeds of the old steppe. In some places, when the permafrost thaws, ancient plant material emerges, almost intact, yellowed grass blades from a summer that ended 20,000 years ago. Those fragments are like whispers telling us what once grew here, what once fed the herds, what once kept this place alive. And if the vision of Pleistocene Park ever comes true, perhaps the mammoth steppe will roar again, not just in memory, but under a cold sun, with the wind rattling the grass as it did in the age of ice. It is the smell that reaches you first, a strange, almost sweet scent, like damp hay mixed with something metallic. Then you see it, a mound of earth, and ice half collapsed, with tufts of coarse brown hair sticking out like the bristles of a giant brush. As you step closer, the shape becomes clear. A massive head with a long curve of ivory sweeping out from it lies frozen in place. You're looking into the cloudy, half-closed eye of a woolly mammoth that has been dead for tens of thousands of years. The Ice Age was the age of giants, and the woolly mammoth was one of its undisputed monarchs, standing up to 11 feet at the shoulder and weighing as much as 6 metric tons. These enormous herbivores were built for survival in cold, open environments. Their thick, shaggy coats kept out the worst of the wind, while a dense layer of fat up to 4 inches thick insulated them against sub-zero temperatures. Even their ears were small and rounded to minimize heat loss, a stark contrast to their modern elephant cousins. Mammoths thrived across the mammoth steppe from Western Europe to North America. They grazed on grasses, sedges, and herbs, using their curved tusks to sweep aside snow in winter. Herds likely moved seasonally, following fresh growth and avoiding the deepest snow. Young calves were raised in close-knit family groups, led by a matriarch much like modern elephant herds. Humans and mammoths crossed paths countless times, and our relationship with them was both practical and symbolic. They were a source of food, clothing, shelter, and tools. Mammoth bones could form the framework for huts covered in hides for insulation. Their ivory tusks were carved into tools, ornaments, and even art-delicate figurines of animals and humans that have survived to this day. Some archaeological sites, like Mezhyrich in Ukraine, contain elaborate mammoth bone structures that may have been permanent winter homes for Ice Age hunters. But mammoths were not just resources, they were also subjects of reverence. Cave paintings and carvings depict them in careful detail, suggesting that they held a place in Ice Age belief systems. Perhaps they were respected as powerful spirits providers or guardians of the grasslands. Despite their size and adaptability, mammoths began to vanish toward the end of the Ice Age. The exact cause is still debated. Climate change played a major role. Warming temperatures shrank their grassland habitat, replacing it with forests and wetlands. Food became scarcer, and the open plains where mammoths once roamed gave way to landscapes less suited to their grazing style. At the same time, human hunting pressure increased. While it's unlikely that humans alone wiped out mammoths across their vast range, archaeological evidence shows that we hunted them extensively, especially in regions where food options were limited. The combination of shrinking habitat and hunting pressure may have pushed mammoth populations past the point of recovery, yet they didn't all vanish at once. Most mammoths were gone from mainland Eurasia and North America by about 10,000 years ago, but small populations survived in isolated refuges. On Wrangel Island, off the coast of Siberia, a group of dwarf mammoths lived until about 4,000 years ago, meaning they were still around when the pyramids of Egypt were being built. Another small population persisted on St. Paul Island in Alaska until roughly 5,600 years ago. The preserved remains of mammoths in Siberia's permafrost have given scientists an unparalleled look into their biology. Some specimens are so well preserved that their stomach contents, muscle tissue, and even blood have survived. These remains have sparked serious discussion about de-extinction, using ancient DNA to clone or genetically engineer mammoths or mammoth-like elephants to reintroduce into modern ecosystems. Proponents argue that restoring mammoths to Arctic tundra could help revive grasslands, slow permafrost thaw, and even mitigate climate change. Critics question the practicality and ethics of such a project. Whether or not mammoths walk the earth again, their legacy continues in modern elephants, their closest living relatives. Behavioral studies suggest that mammoths likely shared many traits with elephants: long memories, complex social bonds, and mourning rituals for their dead. If you imagine a herd of mammoths standing silently around the body of a fallen calf, touching it gently with their trunks, you're probably not far from the truth. Now, picture yourself as an Ice Age hunter encountering a mammoth on the steppe. The wind is in your favor, carrying your scent away. You and your companions creep forward, spears ready, aiming for the flank or behind the shoulder where a thrust might pierce a lung. The mammoth turns, trumpeting loudly, ears flaring, and charges. The ground shakes beneath your feet. The hunt is dangerous. One wrong move, and you could be crushed. But the reward, if successful, will feed and clothe your people for months. Even today, standing beside the frozen remains of a mammoth is humbling. You can run your hand over hair that last blew in the Ice Age wind, touch a tusk worn smooth by decades of use, and see in its massive bones the sheer scale of life that once roamed here. It is a reminder that the Ice Age was not just an era of cold. It was a world filled with abundance, diversity, and creatures that still have the power to awe us tens of thousands of years later. The mammoth story is not simply one of extinction, it's also one of endurance. For hundreds of thousands of years, they adapted to shifting climates spread across continents and coexisted with predators, including us. Their disappearance was not inevitable until the world they knew began to change too quickly for them to keep pace. In the end, the Ice Age gave us many gifts: fertile soils, reshaped landscapes, and lessons about resilience and fragility. The mammoth embodies all of those things: majestic, powerful, and in the end, mortal. And somewhere in the frozen north, under meters of permafrost, more of them are waiting, waiting for the day when the ice lets go and their story surfaces again. The forest is quiet, too quiet. No birds call from the branches above. No rustle of small animals moves through the undergrowth. You pause, aware of the heavy stillness, and then you see it. Between the tree trunks, a shadow moves. Massive shoulders sway as a hulking shape glides forward, head low, the air around it shimmering with the smell of predator. This is no wolf, no bear. This is a cave lion. During the Ice Age, Panthera spelaea. The Eurasian cave lion was the largest cat to ever walk the northern continents in recent history. Some males stretched over 10 feet from nose to tail tip, with a shoulder height of nearly 4 feet and weighing upwards of 800 pounds. They were bigger than modern African lions, with longer legs built for running down prey on open steppes. Despite their name, cave lions didn't actually live in caves most of the time. The name comes from the fact that many of their remains and stunning Ice Age paintings have been found in caves. In Chauvet Cave in France, cave lions prowl across the walls in charcoal outlines. Their ears flattened their bodies in mid-stride. These were apex predators, feared and respected by the humans who shared the land with them. The cave lion's range was vast, stretching from Western Europe across Siberia and into Alaska and Canada via Beringia. They were part of a larger group of megacats that also included the American lion Panthera atrox, which may have been even larger. Genetic evidence shows they were close relatives of modern lions, but differences in their skulls and coats suggest they were adapted for colder climates, likely with lighter or no manes to help with heat regulation during hunts. On the Mammoth steppe and in the boreal forests, cave lions hunted some of the largest animals alive at the time: bison, reindeer, wild horses, even young mammoths. They may have hunted in groups like modern lions, but there's also evidence suggesting they could operate alone, especially when stalking smaller prey. The relationship between humans and cave lions was complicated. They were direct competitors for food, but humans also used their pelts and claws, and sometimes depicted them in art with a mix of fear and admiration. At some sites, lion bones show cut marks from butchering, suggesting they were hunted or at least scavenged for meat and materials. In rare cases, cave lion teeth and bones have been found in what appear to be ritual contexts, hinting at a symbolic or spiritual role in human culture. One of the most astonishing cave lion discoveries came from the Siberian permafrost in 2015, when 2 mummified cubs were found perfectly preserved in the frozen ground. They were about 12,000 years old, with fur whiskers and even tiny teeth intact. These cubs gave scientists their first real look at what the animal's coat looked like, shorter than modern lions with faint spots, much like those on modern lion cubs, which may have helped camouflage them in grass or snow. As formidable as they were, cave lions began to disappear toward the end of the Ice Age. Their decline likely mirrors that of their prey. As the climate warmed and forests replaced the open steppe, large herbivore populations shifted and shrank. With fewer bison horses and reindeer to hunt, cave lions lost their main food sources. Increased human hunting pressure, both on lions themselves and their prey, likely played a role as well. By around 12,000 years ago, cave lions were gone from most of their range. But imagine for a moment being an Ice Age human, sharing a hunting ground with these giants. You're tracking reindeer along a riverbank. When you see paw prints in the mud, each one the size of your open hand, the claw marks visible at the tips, you know they're fresh. The edges are still crisp. Suddenly, a low growl rolls through the trees, and your heart pounds as you catch sight of tawny fur sliding between the trunks. In that instant, you're no longer the top predator. For humans of the Ice Age, the presence of cave lions meant constant vigilance. Camps were likely chosen for defensibility, with fires kept burning through the night to deter prowling predators. Children and injured members of the group had to be protected, and kills had to be guarded against theft. Just as we competed with wolves and bears, we competed with lions, not always successfully. And yet the fascination remained. The fact that cave lions appear so often in Ice Age art suggests they were more than just threats. Perhaps they were admired for their strength, grace, and hunting skill, the same qualities humans valued in themselves. Some researchers speculate that lions might have been totem animals for certain groups, embodying the qualities they sought to emulate. Today, the cave lion's legacy survives in bones, mummified cubs, and those haunting, confident outlines on cave walls. They are reminders that the Ice Age was not only a time of cold and ice, but of predators so powerful that even the most skilled hunters had to tread carefully. If you stand in the darkness of Chauvet Cave and let your torchlight play over the painted lions, you can almost feel their eyes following you. The flicker of the flame makes them seem to move, padding silently through the shadows. And for just a moment, you remember what it was like to walk through a world where another hunter's breath could be the last thing you ever heard. The air here feels different, drier, thinner. You're standing at the edge of a canyon, and below you runs a ribbon of pale, milky water. The banks are sheer and scoured as if some enormous hand once clawed at the earth. This is no ordinary river valley. This is a relic of the Ice Age megafloods. Toward the end of the last glacial period, the world was a patchwork of enormous ice-dammed lakes, some of them so vast they seemed like inland seas. We've already met Lake Agassiz, but it was not alone. In the Pacific Northwest, there was glacial Lake Missoula, formed when the Cordilleran ice sheet pushed into what's now Montana and created a wall of ice hundreds of meters high. Behind it, meltwater filled valleys and plains, building up an unimaginable volume of water. When that ice dam failed, the result was catastrophic. Picture this: in a matter of hours, an ice wall the size of a small mountain collapses. The lake drains in a torrent so fast, it's hard to find modern comparisons. The flow rate may have reached 10 times that of all the world's rivers combined. The water roared westward, racing across what's now Idaho and Washington at highway speeds. It slammed into the basalt plateau of eastern Washington, ripping away soil and rock carving channels dozens of meters deep. Boulders the size of trucks tumbled like pebbles. Entire hillsides were planed off, leaving behind bare, polished rock. The landscape that resulted is called the channeled scablands, an otherworldly terrain of deep coulees, dry falls, and ripple marks so huge they're only visible from the air. At places like Dry Falls, you can stand on a cliff and imagine the wall of water that once plunged over it 5 times wider and twice as tall as Niagara Falls. And here's the twist: this didn't happen just once. Evidence suggests that glacial Lake Missoula filled and drained dozens of times over several thousand years. Each time the ice advanced again, blocking the Clark Fork River, and each time the dam eventually gave way, repeating the cycle of destruction. For Ice Age humans living in the region, these floods would have been apocalyptic. Camps, hunting grounds, and travel routes could vanish overnight. The roar of the water would have been audible for miles, and the ground would have trembled with its force. Even far from the flood path, the climate affects cooler air, altered river systems, and shifting animal migrations would have been felt. These megafloods weren't limited to North America. In Siberia, the Yenisei River basin experienced massive outbursts from glacial lakes, sending water surging north into the Arctic Ocean. In Europe, the English Channel may have been carved in part by catastrophic flooding when ice-dammed lakes burst between Britain and mainland Europe. And in Central Asia, meltwater from retreating glaciers created inland seas that grew and shrank in dramatic pulses, changing the course of rivers and shaping human settlement patterns. For decades, the idea of such massive floods was controversial. In the early 20th century, geologist J. Harlan Bretz proposed that the channeled scablands were formed by a single catastrophic flood. At the time, most scientists favored gradualism, the idea that landscapes are shaped slowly over long periods. The thought of one flood reshaping thousands of square kilometers in days seemed impossible. It wasn't until the mid-20th century, when aerial photography and more detailed geological studies were available, that Bretz's theory was vindicated. These floods also left behind subtler evidence: thick deposits of silt in low-lying areas, layers of gravel that could only have been carried by powerful currents, and stranded erratic boulders, dropped by icebergs carried in the floodwaters. In some places, you can stand next to one of these boulders, knowing it was plucked from a mountainside hundreds of miles away, and set down gently when the flood's ice raft melted. What's remarkable is how quickly nature recovered after each event. Within decades, plants reclaimed the scoured channels and animals returned to graze. But for humans, the memory of such events may have lasted for generations. Some oral histories from indigenous peoples of the Pacific Northwest speak of great floods that reshaped the land, sweeping away everything in their path. While these stories are layered with cultural meaning, the echoes of real geological events are hard to miss. Standing here today, you might find it hard to imagine so much water in a place that is now semi-arid. The coulees are dry, the riverbeds empty, except for occasional seasonal flows. But close your eyes, and you can almost hear it, a deep, unbroken roar, the crash of waves against rock, the hiss of spray carried high into the air. It's tempting to think of the Ice Age as static, a world of frozen landscapes locked in place for millennia. But the truth is, it was an era of sudden violent change. Megafloods were part of that reality, reminders that ice and water can transform a continent not over millions of years, but in a single week. And the traces are still here. In the channeled scablands, in giant gravel bars and dry waterfalls, in the erratics scattered across the Columbia Basin, each one is a breadcrumb leading back to a time when the land itself was caught between ice and water won. The wind hisses over the tundra, tugging at the hood of your fur parka. Ahead of you, the ground is not flat, but pocked with shallow depressions and mounds as if the earth itself has been breathing in and out. You step carefully, because here the ground is not entirely solid. Beneath the thin crust of moss and lichen lies a frozen world, a relic of the Ice Age permafrost. Permafrost is soil rock or sediment that has remained frozen for at least 2 consecutive years, but in many places it's been frozen for tens of thousands of years. During the last Ice Age, vast areas of the northern hemisphere were locked in this icy embrace, stretching from Alaska and Canada across Siberia and into northern Europe. Even in places without massive glaciers, the soil stayed frozen year-round, preserving everything it held: roots, seeds, bones, even the bodies of animals and humans. In summer, only the uppermost layer, called the active layer, thawed just enough to support a short-lived burst of plant growth. Grasses, sedges, and mosses flourished briefly before the cold returned, feeding herds of grazing animals and the predators, including humans, who followed them. But the frozen layer below remained undisturbed, a deep archive of the Ice Age. The permafrost's preserving power is legendary. In Siberia and Alaska, it has yielded whole mammoths, woolly rhinoceroses, bison, and horses their fur flesh, and even blood intact. In some cases, plants pulled from the frozen soil have been coaxed back to life like a 32,000-year-old silene flower grown from seeds recovered by Russian scientists in 2012. That's not just preservation, that's resurrection. But permafrost is more than a natural freezer. It's also a massive climate regulator. Locked within it is an immense store of organic carbon plant material that, frozen and unable to decay, has built up over millennia. During the Ice Age, this carbon stayed safely trapped, part of a balance that helped maintain the planet's climate. When permafrost thaws, that balance shifts. The once frozen organic matter begins to decompose, releasing carbon dioxide and methane into the atmosphere. Today, as modern warming accelerates, scientists are increasingly concerned about the permafrost feedback loop. The more it thaws, the more greenhouse gases are released, which causes more warming, which thaws more permafrost. During the Ice Age's warm phases, similar bursts of thaw may have influenced climate shifts, though on a slower scale than today. In some places, thawing permafrost leaves behind striking landforms. Thermokarst, lakes form when ice-rich ground melts and collapses, filling with meltwater. Pingo, mounds ice-cored hills, rise from the tundra as water freezes and expands beneath the surface. From above the patterned ground of the Arctic networks of polygons, stripes, and circles, marks where the soil has cracked and shifted from cycles of freezing and thawing over thousands of years. For Ice Age humans, permafrost was both a challenge and an advantage. Digging into it was nearly impossible without fire or heavy tools, so deep storage pits for food or water were rare. But its stability meant that landscapes stayed largely the same over generations, with rivers, hills, and valleys holding their form for centuries. And in summer, the thin thawed layer above could yield edible plants, while animals grazed on the fresh growth. Yet the frozen ground could also hide dangers. In some areas, Ice Age hunters crossing frozen riverbanks or marshes might have stepped onto thin ice covering waterlogged ground, breaking through and sinking into freezing mud. The same processes that preserve remains today would have sealed them away back then, leaving their tools and bones to be found thousands of years later. One eerie example of permafrost's grip came in 2016 when an anthrax outbreak in Siberia killed thousands of reindeer and sickened dozens of people. The source, a reindeer carcass that had been frozen since the 1940s, thawed during a heat wave and released dormant spores. It was a chilling reminder that permafrost doesn't just preserve flesh, it preserves pathogens too. During the Ice Age, it may have held bacteria and viruses that infected both humans and animals, locking them away for millennia. But permafrost isn't just about what it holds, it's about the way it shapes the world above. During the last Ice Age, its presence influenced where plants could grow, where animals migrated, and where humans settled. It created hard frozen highways in winter and soft, boggy traps in summer. It determined the thickness of river ice, the stability of slopes, and the reliability of water sources. If you crouch down today on an Arctic hillside and scrape away the top layer of moss, you'll find the ground turn solid and icy within inches. You might even hit a vein of pure ice, clear and ancient, formed when meltwater froze in the soil thousands of years ago. Break off a piece, and you're holding a fragment of the Ice Age itself, unchanged since the day it formed. Imagine an Ice Age night on the permafrost plains. The ground is hard as stone, the stars blaze overhead, and the air is so still you can hear the distant crunch of a mammoth's steps. The frozen earth beneath you is layered with time, summer after summer, of grass roots, autumn leaves, and winter snow pressed down and sealed in ice. Somewhere below, perhaps lies the body of an animal that died long before your people arrived, waiting patiently for the day the ice lets it go. And when it does, the story it tells will not be just about the animal, but about the climate, the plants, the soil, and the whole world it lived in. The permafrost is the Ice Age's filing cabinet, and every thawed layer is a new page in a very old book. The difference now is that the book is being opened all at once. The Ice Age permafrost is thawing faster than it has in thousands of years, revealing treasures and warnings in equal measure. For scientists, it's a rare opportunity to study the past in astonishing detail. For the rest of us, it's a reminder that the frozen ground beneath our feet is not as eternal as it feels, and that the Ice Age, for all its distance and time, is still with us, shifting and breathing just below the surface. The air smells faintly of salt and decay, and the gulls are circling above you, riding the cold wind blowing in from the sea. You stand on a rocky cliff that drops steeply to the water below, and just offshore the pale shapes of islands rise like sleeping beasts from the gray waves. But these aren't true islands, they're the exposed shoulders of a much larger landmass, one that connected continents during the last ice age. You're looking at what was once the great Bering Land Bridge. During the height of the last glacial maximum, so much water was locked up in continental ice sheets that global sea levels dropped by over 120 meters. In the far north, this exposed a vast plain between Siberia and Alaska, a stretch of dry land nearly 1,000 miles wide at its greatest extent. Today, we call it Beringia. And it was not just a migration route. It was a thriving ecosystem, all its own. Beringia connected Asia and North America, but it wasn't a frozen wasteland. Instead, it was a cold, dry grassland, an extension of the Mammoth steppe home to herds of bison horses, mammoths, and caribou. Wolves, lions, and bears prowled its plains. And humans, too, walked here, hunting, gathering, and slowly moving between continents. For decades, scientists debated how and when the first people arrived in the Americas. The traditional view held that humans crossed Beringia and then quickly moved south through an ice-free corridor between the retreating Laurentide and Cordilleran ice sheets around 13,000 years ago, giving rise to the Clovis culture. But more recent evidence suggests a more complex story, one in which people may have lived in Beringia for thousands of years before moving deeper into the Americas. This Beringian standstill hypothesis proposes that a population of early humans migrated from Siberia into Beringia during a warm period more than 20,000 years ago. Then, as the ice sheets expanded again, they became isolated, cut off from Asia by glaciers and from the rest of North America by ice barriers. For millennia, they survived in the steppe tundra of Beringia, adapting to its harsh winters and brief intense summers. Eventually, when the glaciers retreated and new coastal or inland routes opened, their descendants moved south, spreading through the Americas. Archaeological sites along both sides of the former land bridge offer tantalizing clues. In Siberia's Yana River site, artifacts dating back more than 30,000 years show that humans were thriving at extreme latitudes. In Alaska and the Yukon, ancient tools, butchered animal bones, and even traces of hearths suggest human presence before the Clovis era. Offshore beneath the waters of the Bering and Chukchi seas lie the drowned remains of countless camps, hunting grounds, and migration trails. Beringia wasn't just a bridge for humans. Animals moved in both directions, sometimes in great waves as climates shifted. Horses and camels, which evolved in North America, migrated into Asia. Mammoths, lions, and brown bears came the other way. Even plants crossed their seeds, carried in the fur of animals, or blown by the relentless winds. The mixing of species helped shape the Ice Age ecosystems of both continents. For Ice Age humans, Beringia offered resources, but also challenges. Winters were long and dark, with temperatures plunging far below freezing. Summer brought swarms of biting insects. Food could be abundant, large herds grazed the plains, but it required skill and cooperation to hunt successfully. Hunters likely used stone-tipped spears, atlatls, and coordinated drives to bring down bison or reindeer. In winter, people may have built shelters of hide and bone, using driftwood or imported timber for fires, and stored meat in frozen caches to last through the hungry months. And yet, for all its hardships, Beringia was a crossroads of cultures. Here, knowledge and technology from Asia met the ingenuity and adaptability that would carry humans into entirely new worlds. The tools, clothing, and survival strategies honed in this place would prove essential as people ventured into unfamiliar environments. Whether dense forests, high mountains, or coastal zones teeming with marine life. When the Ice Age ended and the glaciers melted, the seas rose again. Slowly, the land bridge drowned, cutting off the direct route between Asia and North America. What had been a vast windswept plain became a shallow seabed, now home to crabs and walruses instead of mammoths and horses. For the people who had once traveled freely between continents, the change would have been profound. Relatives and allies across the strait became unreachable except by dangerous sea voyages. The ancient highway closed, and its history was buried beneath the waves. But echoes of Beringia remain in the DNA of indigenous peoples across the Americas, in the bones of animals found on both continents, in the tools and artifacts preserved in frozen ground. Even the languages spoken today in parts of Siberia and Alaska hint at ancient connections. Standing here on the cliff, you can imagine the view 20,000 years ago. Instead of ocean, there's a rolling expanse of grass and tundra stretching to a hazy horizon. Herds of bison move slowly across it, while mammoths graze near shallow lakes. In the distance, a line of human figures moves steadily eastward, their silhouettes sharp against the low sun. They are following a trail that has no beginning or end, only the open land, the cold wind, and the promise of something beyond. And somewhere under the waves, between here and there, their footprints still lie pressed into the earth, waiting for the day we can find them again. The sun is low, turning the horizon into a thin band of gold. You're standing not on solid ground, but on a frozen expanse of ice that stretches as far as you can see. It's not the flat, endless white of an inland ice sheet. This is the sea itself, locked in winter's grip. This is the Ice Age's seasonal sea ice frontier, and it's every bit as alive as the land. During the last glacial period, the polar regions were far colder than they are today. Sea ice spread much farther south, extending into waters that now remain ice-free year-round. In the Arctic winter, ice reached well into the North Atlantic, forming a floating barrier that shifted with the seasons. In the southern hemisphere, Antarctic Sea, ice pushed farther toward the equator, affecting weather patterns around the globe. To Ice Age humans and animals, sea ice wasn't just a frozen obstacle. It was a hunting ground, a highway, and sometimes a home. For predators like polar bears and Ice Age wolves, the edge of the ice was where seals surfaced to breathe, making it a rich feeding zone. For humans living along Ice Age coasts, the ice offered access to marine mammals, fish, and seabirds, and in some cases, a more direct route between distant hunting territories. Imagine walking across a frozen bay in the deep of winter. Beneath your feet is a sheet of ice a meter thick, groaning faintly as the tide shifts beneath it. To the north, the ice blends seamlessly into the pack. Pressure ridges rise like frozen waves, where sheets have collided and buckled. In the distance, a lead of open water steams in the cold air, its dark surface dotted with the heads of seals. In the Ice Age, Arctic coastal peoples may have ventured onto the ice using skin-covered boots and sleds drawn by dogs or other domesticated animals. Some could have built temporary camps right on the ice using snow blocks for walls and sealskin for shelter. The ice's surface wasn't just a blank sheet, it was a living map of cracks, ridges, and melt pools, constantly changing with the wind and currents. For animals, these frozen seas were equally vital. Ringed seals, bearded seals, and walruses used the ice as haul-out platforms for resting, breeding, and raising pups. Narwhals and belugas navigated through leads and polynyas areas of persistent open water in the ice, feeding on fish and squid. Migratory birds nested on ice-bound cliffs and islands, feasting on the marine life, drawn to the nutrient-rich waters at the ice edge. The presence of so much seasonal sea ice also influenced global climate. The ice's bright surface reflected sunlight back into space, helping to keep the planet cool. When it expanded in winter, it locked away vast areas of ocean from the atmosphere, affecting evaporation rates and weather systems far beyond the poles. Its growth and retreat were part of the Ice Age's rhythm, linked to shifting winds, ocean currents, and even the timing of monsoon rains thousands of miles away. But sea ice could be dangerous. Pressure ridges could trap travelers, shifting leads could open without warning, and storms could break up the ice beneath a camp in hours. A hunter, stalking seals, might find himself stranded on a drifting floe, carried silently out to sea. Even in calmer conditions, the ice was a place of constant vigilance. You had to read its creaks, watch for the faint shimmer of thin ice, and know by the wind where it might crack next. Evidence of Ice Age. Sea ice comes not only from ancient shorelines and fossilized remains, but from microscopic clues locked in ocean sediments. Layers of diatoms, tiny algae that bloom along the ice edge, reveal where the seasonal boundary once lay. Traces of ice-rafted debris pebbles dropped by melting bergs mark the reach of drifting ice flows. By piecing together these records, scientists can reconstruct how the ice waxed and waned and how it shaped the ecosystems and climate of the time. The expansion of sea ice during the Ice Age likely made certain coastal migrations easier. Groups moving along shorelines could travel farther without venturing into open water, using the ice as a bridge. In some areas, sea ice may have connected island chains, allowing people to carry heavy loads or hunt from vantage points otherwise unreachable. It also created unique hunting strategies. In modern Inuit traditions, hunters wait at seal breathing holes for hours, sometimes covering themselves in snow to blend in with the ice. Similar techniques may have been used in the Ice Age, with hunters using carved bone or antler-tipped spears to strike when the seal's head appeared. Success meant not just food, but oil, for lamp skins, for clothing, and bones for tools. In spring, as the ice began to break apart, it brought life in abundance. Algae, growing on the underside of the ice, seeded massive plankton blooms in the water, which in turn attracted fish birds and marine mammals. For coastal peoples, this seasonal surge of resources could mark the most important time of the year when stores were replenished after the long winter. When the Ice Age ended, sea ice retreated toward the poles, shrinking the frozen highways and hunting grounds that had existed for tens of thousands of years. Coastal ecosystems shifted, forcing both humans and animals to adapt. For some, like the polar bear, the loss of ice meant a narrowing range and greater competition for food. For others, like humans, it meant turning more toward boats and open water fishing to replace what the ice had once provided. Today, the rhythm of the Ice Age sea ice can still be traced in the sediments beneath the Arctic and Antarctic oceans, and in the survival skills of cultures that live with ice as a fact of life. Standing here, with the wind biting your face, and the horizon a seamless line of white, it's not hard to imagine the world as it was a place where the frozen sea was not an obstacle to be avoided, but a landscape to be learned, navigated, and lived upon. And somewhere beneath this ice, perhaps lies a lost harpoon, a fragment of a sled runner, or the bones of a seal caught long ago. They're reminders that the Ice Age wasn't just about surviving the cold, it was about mastering it, turning the frozen edges of the world into a home. The sky is a hard, cloudless blue, the kind that seems to magnify the sun's glare until it stings your eyes. You're high in the mountains now, far above the grassy valleys where mammoths and bison graze. The air is thin cold and sharp in your lungs, and around you stretches a world of rock, snow, and ice. This is the Ice Age's alpine kingdom. While massive ice sheets dominated the lowlands of North America, Europe, and Asia, high mountain ranges across the globe hosted their own smaller glaciers, local giants sculpting peaks and valleys on a scale just as dramatic. From the Rockies to the Alps, from the Himalayas to the Andes, alpine glaciers were relentless, carving deep cirques and steep-walled valleys, grinding down bedrock into fine flour that rivers would carry for hundreds of miles. Unlike the continental ice sheets, these glaciers ebbed and flowed on a quicker rhythm, advancing in colder decades and retreating during slightly warmer intervals. In the Ice Age, they extended far down valleys that today are green with forest and farmland. In some regions, the glaciers from neighboring valleys merged into a network of ice tongues that resembled smaller versions of the great ice sheets themselves. Living near these mountains was both a gift and a gamble for Ice Age humans. The glaciers fed rivers with meltwater, ensuring a steady supply even in dry seasons. The valleys below were rich with game, and the slopes offered high vantage points for spot and prey. But the ice was dangerous avalanches, sudden rockfalls, and glacial outburst floods could strike without warning. Evidence from archaeological sites shows that humans ventured high into alpine zones, even during glacial peaks. In the Alps, for example, stone tools have been found on passes once covered by ice suggesting that people crossed these high routes in warmer seasons to hunt, trade, or migrate. They would have worn layered furs and skins, carrying supplies in packs, or on sledges moving carefully across snowfields and unstable scree. Glacial melt also shaped the valleys where people lived year-round. As glaciers advanced, they bulldozed moraines, ridges of rock and debris pushed ahead by the ice. When they retreated, they left behind U-shaped valleys, hanging side valleys with waterfalls and glacial lakes. Some of these lakes became seasonal fishing grounds. Others, dammed by unstable moraines, were dangerous reservoirs waiting to burst. The animals of the alpine world were as specialized as the people who hunted them. Ibex and wild goats clung to cliff faces, using their agility to avoid predators. Woolly rhinoceroses grazed the alpine meadows during the brief summer thaw. Snow leopards and wolves prowled the edges of the ice, preying on animals that ventured too far from safety. Bird migrations passed overhead, their calls echoing off the cliffs, while marmots and pikas gathered food for the long winter. In the Himalayas and the Andes, humans adapted to extreme altitudes by developing remarkable endurance and lung capacity. In the Andes, people used high passes to trade between mountain valleys long before the Ice Age ended, carrying obsidian shells and other goods from distant regions. In the Himalayas, seasonal hunting camps likely dotted the lower slopes, taking advantage of summer grazing migrations. The glaciers themselves were dynamic presences, creaking, groaning, and occasionally booming, with the sound of ice breaking away. In spring and summer, meltwater roared from their snouts sometimes in braided streams that shifted course daily. At night, temperatures plunged, and the valleys filled with katabatic winds, cold air pouring down from the ice in invisible rivers. For Ice Age peoples, these mountains may have held spiritual significance. In many later cultures, high peaks are considered the dwelling places of gods, spirits, or ancestors. It's not hard to imagine Ice Age hunters looking up at a glacier shining under the moon and feeling that they were in the presence of something vast, alive, and beyond human reach. Some of the most remarkable artifacts of Ice Age alpine life have been found as glaciers have receded in modern times. In the Yukon, archaeologists have recovered atlatl darts, wooden tools, and scraps of hide from melting ice patches preserved for thousands of years. In the Alps, Ötzi, the Iceman, though much younger than the last glacial maximum, was discovered with his clothing tools and even a half-finished bow, offering a rare glimpse of life and death in the high mountains. The retreat of Ice Age alpine glaciers also triggered changes far beyond the mountains themselves. As the ice melted, sediment-rich water flowed into rivers and lakes, nourishing floodplains that became fertile ground for early agriculture thousands of years later. The landscapes we now think of as idyllic mountain valleys were in many cases sculpted by the grinding ice of the last glaciation. Standing here, you can see the marks everywhere. The smooth, striated rock beneath your feet was polished by a glacier that retreated over 12,000 years ago. The lake in the valley below is a meltwater remnant still cold and clear, even in midsummer. The jagged peaks surrounding you were once buried under hundreds of meters of ice, their current form shaped by centuries of glacial carving. If you close your eyes, you can imagine the Ice Age scene, a wall of ice filling the valley, its surface fractured with deep blue crevasses, clouds snagging on the peaks, the muffled boom of ice collapsing in the distance. In the thin air, a group of hunters moves along the ridge, their spears tipped with sharpened stone, scanning the slopes for the flicker of movement that might mean meat for the camp below. The alpine world of the Ice Age was harsh, but it was also rich in resources in life and in meaning. It was a place where survival depended on reading the land, the weather, and the moods of the ice itself. And though the glaciers have retreated, the bones of that world remain in every sharp ridge, every hanging valley, every lake cradled high among the peaks. Somewhere deep in the ice of a forgotten cirque, perhaps a hunter's dropped tool, or a strand of mammoth hair still waits. The mountains keep their secrets well, but as the ice continues to melt, those secrets may not stay hidden forever. The air is heavy with moisture, and you can hear the rhythmic rush of waves long before you see the shoreline. The smell of salt mixes with the scent of rotting kelp, and when you step out of the forest onto the beach, the horizon opens before you gray water, stretching to infinity. But this is not the coastline as you know it today. During the Ice Age, the sea was far away, and where you stand now would have been high and dry. Lower sea levels during the last glacial maximum exposed vast stretches of continental shelf, creating coastlines hundreds of miles farther out than they are today. These submerged plains were some of the richest environments of the Ice Age, teeming with fish, shellfish, seabirds, and marine mammals. For humans, they were highways, supermarkets, and meeting grounds all at once. The Kelp Highway hypothesis proposes that early peoples entering the Americas may have traveled along these Ice Age shorelines by boat, moving from one resource-rich patch to another. The kelp forests that fringe these coasts provided food shelter and protection for a staggering variety of species, from sea otters and seals to rockfish and abalone. Even in cold waters, kelp thrives, and its presence would have meant predictable hunting and gathering opportunities year-round. But coastal life wasn't limited to hunting and fishing. Archaeological evidence suggests that Ice Age peoples along the Pacific coasts of Asia and the Americas built semi-permanent camps, processed seaweed and shellfish, and even used fish bones and shells as tools, ornaments, and trade goods. Some sites, like those on Japan's Ryukyu Islands, show that people were skilled mariners, capable of crossing open water to reach new lands. Much of this evidence, however, now lies underwater. As the Ice Age ended and the glaciers melted, sea levels rose more than 120 meters, drowning ancient beaches, estuaries, and coastal settlements. Entire cultural landscapes were swallowed, leaving only scattered hints of their existence. Occasionally, storms or underwater surveys reveal tantalizing finds: stone tools eroded from a submerged cliff, mammoth bones resting on the seafloor, ancient fishing weirs still anchored in place. For Ice Age humans, the coast was both bounty and danger. The ocean could provide a steady diet of fish seals and seabirds, but it could also unleash storms, rogue waves, and sudden changes in tide. People living here had to understand the rhythms of the sea, how to read the wind and swell, when to harvest shellfish safely, and how to navigate by the stars and coastline. Maritime technology in the Ice Age may have been more advanced than we often imagine. Skin-covered boats, dugout canoes, and even simple rafts could have carried people and goods along hundreds of miles of shoreline. These vessels would have been essential not only for travel, but for hunting sea mammals, fishing in deeper waters, and reaching offshore islands. And the coast was more than just a physical place. It was a cultural meeting ground. In many parts of the world, coastal peoples interacted with inland groups exchanging goods, like dried fish shells, hides, and stone for tools, plant foods, and other resources. The sea may have also shaped belief systems. Tide storms and distant horizons could inspire myths of other worlds, gods of the deep, and journeys to lands beyond sight. In some regions, the Ice Age coast was a staging ground for major human migrations. The route into Southeast Asia and Australia, for example, involved crossing a chain of islands and shallow seas land and sea working together to guide and challenge travelers. In the north, the now submerged coasts of Beringia may have been the first American homelands, dotted with fishing camps and seal hunting stations long before inland ice corridors opened. The ocean also shaped animal migrations. Gray whales, for example, may have followed different routes than today, traveling along coastlines now buried beneath the waves. Seabird colonies would have shifted with the changing shape of the land, creating seasonal booms of eggs and chicks for human foragers. Even terrestrial animals, like mammoths, sometimes wandered onto the exposed continental shelves, grazing on grasses that grew where water now lies hundreds of feet deep. Standing on this modern shoreline, you can try to imagine the Ice Age version. The forest behind you gives way to open meadow, stretching for miles toward the distant lower sea. Tidal flats teem with clams and crabs. Offshore kelp beds sway in the current, their fronds sheltering fish and invertebrates. A group of hunters paddles past in skin boats, heading for a rocky islet where seals haul out to rest. In the camp nearby, women tend fires where strips of fish dry in the cold wind, while children gather driftwood from the tide line. But that world is gone buried beneath the sea's slow advance. The same meltwater that fed rivers and lakes inland was also flooding the coasts, swallowing low-lying plains and forcing people to move inland or adapt to new shorelines. Over generations, villages were abandoned, travel routes shifted, and myths were born of lands lost to the sea. Today, marine archaeologists are beginning to explore these drowned worlds. Using sonar underwater drones and divers, they map ancient river channels, hunt for stone tools, and study submerged reefs that were once coastal cliffs. Each discovery adds a fragment to the story of Ice Age life along the water's edge. And there's something deeply compelling about those fragments. They remind us that the Ice Age wasn't just a frozen inland landscape of mammoths and steppe. It was also a time of rich coastal cultures skilled in the ways of the sea. Their stories are still out there, hidden beneath the waves, waiting for the right eyes and hands to bring them back to the surface. If you listen closely to the wind and the water, you might hear them, the creak of a boat in the swell, the call of seabirds, the crash of waves against a long-vanished shore. It's a reminder that the Ice Age was as much about oceans as it was about ice, and that the boundary between land and sea has always been a shifting living thing. The fire burns low, and the wind outside the cave mouth is softer now than it once was. The Ice Age, this vast, restless chapter of Earth's history, has drawn to a close, but its echoes still travel through the land, the water, and the stories people tell. We've walked across the Mammoth steppe, stalked reindeer through snowy passes, and stood on the edge of calving glaciers as icebergs the size of cities crashed into the sea. We've crossed Beringia's wide, windswept plains, drifted along frozen sea ice highways, and navigated the kelp-rich coasts of a world where the shoreline itself was on the move. We've met the giants, woolly mammoths, cave lions, woolly rhinoceroses, and the people who lived alongside them, hunting, crafting, and painting their likenesses on cave walls that still glow with ochre and charcoal. We felt the sudden violence of megafloods, the slow persistence of permafrost, and the thin, exhilarating air of Ice Age mountain passes. We've stood in coastal camps now, deep under the sea, and in alpine valleys, carved to their bones by the grind of ancient ice. And we've watched the glaciers retreat, giving way to forests, meadows, and the warmer breath of the Holocene, while the last mammoths lingered on lonely islands far from the roar of the ice. The Ice Age didn't just vanish, it transformed into the world we know. The rivers we fish, the soils we farm, the myths we pass on, they all carry traces of that frozen age. Even now, in drifting snow, or the crack of lake ice in winter, you can hear its voice. So, rest easy. The Ice Age is over, but it's still here in the quiet places, waiting in the bones of the earth for anyone willing to listen.